If you like the space and learn about its curiosities, consider subscribing to the channel. Thank you for your attention and enjoy the video. The story of the universe begins with an event so powerful, so transformative, that it reshaped the very fabric of existence, the Big Bang. This incredible moment, which happened about 13.8 billion years ago, is widely considered the starting point of everything we know: space, time, energy, and matter itself. But what exactly was the Big Bang? And how did it set in motion the astonishing, ever-expanding cosmos we inhabit today? The term Big Bang can be misleading. It suggests an explosion in the traditional sense, like a firework in the night sky. But in reality, the Big Bang wasn't an explosion that occurred within space. Rather, it was an expansion of space itself. Imagine a balloon with tiny dots on its surface. As the balloon inflates, the dots move away from each other. This is similar to what happened in the early universe, where space stretched and expanded, carrying galaxies and matter outward in all directions. In the beginning, the universe was unimaginably hot and dense, a singular point where the laws of physics as we know them didn't quite apply. Within this cosmic soup, energy transformed into particles, the first building blocks of matter. In fractions of a second, particles collided, merged, and transformed, creating a wild frenzy that eventually gave rise to atoms. Through this process, the universe went from being a simple, seething field of energy to a structured cosmos filled with matter and forces. This initial phase, known as inflation, saw the universe expand exponentially in an incredibly short time. One of the greatest pieces of evidence for the Big Bang is the cosmic microwave background, CMB, often referred to as the afterglow of the Big Bang. Discovered in the 1960s, this faint radiation permeates the entire universe, a remnant from when the universe was just 380,000 years old. At this point, the young universe had cooled enough for electrons and protons to combine into atoms, allowing light to travel freely for the first time. The CMB is like a snapshot of the infant universe, showing us a time when matter was just beginning to clump together, forming the seeds of future galaxies. In addition to the CMB, the expanding universe itself offers powerful evidence for the Big Bang. Astronomers have observed that galaxies are moving away from us, with those farther away receding faster. This discovery, made by Edwin Hubble in the 1920s, indicated that space itself is stretching, pushing galaxies apart. This expansion suggests that, if we rewind the clock, everything was once much closer together, converging back to the dense, hot origin of the Big Bang. The process of cosmic evolution didn't stop there. Over billions of years, gravity took hold, slowly drawing matter together to form stars, galaxies, and clusters. Within these stars, nuclear fusion began creating the elements essential for life: hydrogen, helium, and eventually heavier elements like carbon, oxygen, and iron. When massive stars reached the end of their lives, they exploded in supernovae, scattering these elements across the cosmos, enriching gas clouds that would later form new stars and planets. But the Big Bang is not just about the past. It also raises profound questions about the future. Since the universe is expanding, scientists wonder if it will continue to do so forever. Will it keep stretching until galaxies are so distant that they drift beyond our view, leaving a dark, empty cosmos? Or will gravity eventually halt this expansion, causing the universe to collapse back into itself in a big crunch? Recent discoveries, especially the concept of dark energy, a mysterious force driving the accelerated expansion of the universe, suggest that the cosmos may continue to expand indefinitely, leading to a big freeze where stars burn out and galaxies fade into the darkness. The Big Bang Theory also leads to questions about what, if anything, existed before this grand event. Some scientists propose that the Big Bang was merely one cycle in a series of cosmic expansions and contractions, a never-ending sequence of Big Bangs and Big Crunches. Others suggest that our universe may be one of many in a vast multiverse, each with its own laws and conditions. While these ideas are still theoretical, they push the boundaries of our understanding, inviting us to ponder the true scale and mystery of existence. In essence, the Big Bang is more than just a theory. It's a gateway into the greatest mysteries of the cosmos. It reveals a universe that is constantly evolving, a cosmic dance of creation and destruction that spans billions of years. Every atom in our bodies, every star in the night sky, every galaxy stretching out across the cosmos, all of it began with the Big Bang. The journey that began with the Big Bang set the stage for the formation of the first galaxies, stars, and eventually planets. In those early days, the universe was filled with vast clouds of hydrogen and helium, the simplest and most abundant elements. These gases, under the influence of gravity, began to clump together, forming the very first stars. Known as population 3 stars, these early giants were massive and short-lived, burning their fuel quickly and ending in explosive supernovae. Their deaths spread heavier elements across the universe, seeding the cosmos with the materials necessary for more complex stars, planets, and ultimately life itself. As stars formed and died, they enriched the universe with elements like carbon, nitrogen, oxygen, and iron. This cosmic recycling process laid the foundation for second and third generation stars, stars like our own sun, which formed with these heavier elements in their makeup. This gradual buildup of heavier elements allowed for the formation of rocky planets, leading to the conditions necessary for life to potentially emerge in the vast reaches of space. Meanwhile, gravity didn't just pull stars together. It pulled entire clusters of stars into vast formations we know as galaxies. Galaxies are the sprawling homes of stars, black holes, planets, and all other forms of cosmic matter. Our own galaxy, the Milky Way, formed billions of years after the Big Bang, taking shape through a series of mergers with smaller galaxies. Even today, galaxies continue to collide and merge, creating dynamic cosmic environments where stars are born and die, and where new possibilities for life emerge. In the fabric of space-time, other massive objects began to shape the universe in dramatic ways. Black holes, for example, are some of the strangest and most powerful objects in the cosmos. They form when massive stars collapse under their own gravity at the end of their lives. The resulting black holes have gravitational fields so strong that nothing, not even light, can escape their pull once it crosses the event horizon, the point of no return. These dark, invisible giants are thought to lurk at the centers of nearly all galaxies, including our own. The supermassive black hole at the center of the Milky Way, known as Sagittarius A*, weighs over 4 million times as much as the Sun and plays a central role in the structure and evolution of our galaxy. The formation of the first galaxies and stars marked a turning point known as the cosmic dawn. As the earliest light sources ignited, they began to transform the universe. Light from these first stars started to ionize the surrounding gas, marking the end of the cosmic dark ages, a period after the Big Bang when the universe was still dark and filled with opaque clouds of hydrogen. This reionization process made the universe more transparent to light, allowing us to observe more distant regions of space and to understand the early universe more clearly. Telescopes like the James Webb Space Telescope now allow scientists to look further back in time than ever before, observing galaxies that formed in the first billion years after the Big Bang. In parallel with these discoveries, scientists have been piecing together an even stranger story about the nature of the universe. Most of it is made up of things we can't see or understand yet. Observations show that the universe is filled with dark matter and dark energy, two mysterious substances that account for about 95% of the cosmos. Dark matter doesn't emit, absorb, or reflect light, making it invisible, yet its gravitational effects are crucial for holding galaxies together. Dark energy, on the other hand, is believed to be driving the accelerated expansion of the universe. Its true nature remains one of the greatest unsolved mysteries in physics, challenging scientists to rethink their understanding of matter, energy, and the forces that govern the cosmos. In the midst of these vast cosmic forces, our solar system was born around 4.6 billion years ago from a cloud of gas and dust. As this cloud collapsed, it flattened into a spinning disk with the sun forming at its center. The leftover material began to clump together to form planets, moons, and other celestial bodies. Earth, the third planet from the Sun, formed in this chaotic early environment, eventually developing conditions suitable for life. The birth of our solar system was not a unique event, though. Scientists estimate that there could be billions of planetary systems in our galaxy alone, many of which may harbor planets in the habitable zone. Regions around stars where conditions might allow for liquid water, a crucial ingredient for life as we know it. While Earth was forming, countless other worlds were taking shape across the universe. Some planets in our galaxy, like the gas giants Jupiter and Saturn, are vastly different from Earth, with thick atmospheres of hydrogen and helium. Others, like Mars and Venus, have rocky surfaces but lack the conditions necessary to support complex life. However, icy moons in our own solar system, such as Europa and Enceladus, may have subsurface oceans beneath their frozen surfaces, sparking curiosity about whether microbial life could exist in these hidden waters. Our understanding of the Big Bang and the cosmic evolution that followed has transformed our view of existence, placing humanity within a grand and ancient universe. Yet, every answer we uncover seems to lead to new questions. What was the universe like before the Big Bang, if such a concept is even meaningful? Is there a multiverse, a collection of multiple universes with different laws of physics? How does dark matter interact with ordinary matter? And will we ever understand dark energy's true nature? These mysteries fuel our ongoing journey to understand the cosmos. The Big Bang is a cornerstone of modern astronomy, providing a framework for understanding how the universe came into being. As telescopes improve and new technologies emerge, scientists hope to probe deeper into the origin of galaxies, the formation of the first stars, and the evolution of planetary systems. Each new discovery brings us closer to answering the profound questions that the Big Bang raises, and to understanding our place in the universe. The exploration of the universe doesn't just satisfy our curiosity, it redefines what it means to be human. We are made of star stuff, forged in the cosmic furnace of stellar explosions, and scattered across the universe in waves of creation. Our atoms were once part of distant stars, now long gone. And in this sense, we are deeply connected to the cosmos. As we gaze up at the night sky, we are looking into our own past, seeing the light of stars and galaxies as it was millions or even billions of years ago. Every step we take to understand the Big Bang is a step toward understanding the fabric of our own existence, a testament to the power of human curiosity in unraveling the mysteries of the cosmos. As we delve deeper into the mysteries of the universe, it becomes clear that the Big Bang is only the beginning of a much larger and more intricate story. One of the most compelling aspects of this story is the emergence of structure within the cosmos. After the initial explosion of energy and matter, the universe was still largely chaotic and uniform, but small fluctuations in the density of matter set the stage for something extraordinary. Tiny clumps of matter began to attract more matter, growing in size and forming the first seeds of cosmic structure. Over billions of years, these clumps became the galaxies, stars, and planets that populate the cosmos today. The vast cosmic web that we observe today, with its filaments of galaxies separated by immense voids, is the result of this early clustering process. Galaxies are not scattered randomly across the universe. Instead, they follow an intricate pattern, much like a vast cosmic tapestry. This structure is shaped by the gravitational pull of dark matter, which acts as a framework around which galaxies form and cluster. The discovery of this cosmic web was a breakthrough in understanding the large-scale structure of the universe, providing a window into how gravity has sculpted the cosmos over time. Among the most fascinating inhabitants of this cosmic web are the quasars, incredibly bright and energetic objects found at the centers of young galaxies. Powered by supermassive black holes consuming vast amounts of material, quasars can outshine entire galaxies and are some of the most distant objects we can observe. They serve as beacons, allowing us to peer into the early universe and study conditions just a few billion years after the Big Bang. Quasars not only illuminate their surroundings, but also provide insight into the behavior of black holes and the evolution of galaxies. While quasars are awe-inspiring, they are only one piece of the puzzle in understanding the role of black holes in cosmic evolution. In the heart of nearly every galaxy, including our own Milky Way, lies a supermassive black hole, millions to billions of times the mass of the Sun. These giants are believed to play a crucial role in regulating the growth of galaxies. When a black hole at a galaxy's center becomes active, it can emit powerful jets and winds, blowing away gas and dust and slowing down star formation. This feedback process helps to explain why galaxies grow in size at a certain rate and why there are limits to the number of stars they contain. Beyond individual galaxies, the universe itself continues to expand, driven by a mysterious force known as dark energy. Unlike gravity, which pulls objects together, dark energy pushes them apart, causing the expansion of the universe to accelerate. This discovery, made in the late 20th century, was a shock to scientists, as it contradicted the previous belief that gravity would eventually slow down the expansion. Dark energy now accounts for about 68% of the total energy in the universe, yet we know very little about its nature. It remains one of the most profound mysteries in cosmology, challenging our understanding of physics and the ultimate fate of the universe. This accelerated expansion suggests that galaxies are moving away from each other faster and faster, and if it continues indefinitely, it could lead to a scenario known as the Big Freeze. In this future, galaxies would become so distant from one another that their light would fade from view. Stars would eventually burn out, and new stars would cease to form as galaxies are left isolated in a dark, cold universe. This concept, though distant and abstract, gives us a glimpse of the potential long-term future of the cosmos, a universe in which the vibrancy of life and light may one day cease. While the Big Freeze presents one possible end, other scenarios challenge this vision. Some theories propose a Big Rip, where dark energy becomes so dominant that it eventually tears apart galaxies, stars, planets, and even atoms themselves. Alternatively, the universe might undergo a Big Crunch, in which gravity reverses the expansion, pulling everything back into a single dense point, possibly leading to another Big Bang and a cyclical universe of endless creation and destruction. Each of these theories pushes the boundaries of our imagination and reveals the uncertainties that still cloud our understanding of cosmic destiny. Despite these mysteries, humanity's exploration of the cosmos has already brought us to remarkable heights. With each new discovery, we peel back another layer of the universe's history, getting closer to understanding our place within it. From the first stars to the possible existence of other universes, the story of the cosmos is one of constant evolution and interconnectedness. And as we continue to explore, we not only uncover facts about distant galaxies and black holes, but also deepen our knowledge of Earth, of life, and of ourselves. One of the most exciting developments in recent years has been the search for exoplanets, planets outside our solar system that could potentially support life. Since the first confirmed discovery of an exoplanet in the 1990s, scientists have cataloged thousands of these distant worlds, with many located in the habitable zones of their stars, where conditions might be right for liquid water. This raises the tantalizing possibility that life could exist elsewhere in the universe, whether in the form of simple microbes or even complex organisms. The search for life beyond Earth has taken on new dimensions with the discovery of water and organic molecules in unexpected places within our own solar system. Moons like Europa and Enceladus, orbiting Jupiter and Saturn, have icy surfaces but are thought to harbor oceans beneath their crusts. These hidden oceans, heated by gravitational interactions with their parent planets, could offer environments where life might exist, shielded from the harsh conditions of space. Similarly, Mars, with its history of liquid water, has become a prime target for exploration, with missions seeking signs of past or even present microbial life. Beyond our galaxy, scientists are also looking at the atmospheres of distant exoplanets for signs of biosignatures, chemical indicators that could suggest biological activity. The detection of gases like oxygen, methane, or even complex organic molecules in an exoplanet's atmosphere could hint at the presence of life. This area of research, though still in its infancy, has the potential to revolutionize our understanding of life's place in the universe and to answer the age-old question, are we alone? The search for extraterrestrial life also connects to our understanding of how life began on Earth. Studying the chemistry of life and the conditions that allowed it to flourish here offers insights into the types of environments that might support life elsewhere. From the deep-sea hydrothermal vents to the extreme heat of volcanic springs, life on Earth has proven resilient and diverse, adapting to conditions once thought inhospitable. These discoveries have broadened the range of possible habitats we might find on distant worlds and have fueled our hopes of finding life beyond our planet. As we uncover more about the origins and evolution of the universe, we are reminded that the cosmos is a place of endless wonder and possibility. The universe is not static, but a constantly changing landscape where stars are born, planets form, and perhaps life emerges. The Big Bang set this cosmic dance in motion, creating a universe that evolves, grows, and fills with incredible diversity. It's a journey that may have started with a single explosion, but it has unfolded into a vast and intricate masterpiece that continues to inspire and astonish us. Our exploration of the cosmos is a testament to human curiosity, a drive to understand not just where we came from, but where we are headed. The stars we gaze upon at night are more than just points of light. They are beacons from distant times and places, reminders that we are part of a larger story that spans billions of years. And while we may never have all the answers, the pursuit of knowledge propels us forward, illuminating the mysteries of the Big Bang, the evolution of galaxies, and the possibility of life in the cosmos. The journey into the cosmos doesn't just deepen our knowledge, it reshapes our perception of reality, revealing the universe as a vast, interconnected tapestry of matter, energy, and fundamental forces. As we push the limits of what we know, we encounter concepts that stretch the imagination, such as parallel universes, quantum fluctuations, and the nature of consciousness within the fabric of space and time. These ideas remind us that the universe is not only stranger than we imagine, but stranger than we can imagine. One of the most mind-bending ideas to emerge from modern cosmology is the concept of the multiverse. While the Big Bang explains the origin of our observable universe, some scientists believe that our universe might be just one of countless others, each with its own unique laws of physics. In this framework, known as the multiverse theory, other universes could have entirely different configurations, some without stars, others with physical laws so alien they defy our understanding. The possibility of a multiverse arises from theories in quantum mechanics and cosmic inflation, suggesting that our universe is merely one bubble among an endless sea of cosmic bubbles, each containing its own version of reality. The idea of a multiverse is not just theoretical. It has practical implications for our understanding of life and existence. If there are infinite universes, then there could be versions of ourselves in other realities, living out different lives with different choices. This concept, known as the many-worlds interpretation, suggests that every decision we make might branch off into a new universe, where alternate versions of ourselves experience different outcomes. It's a thrilling yet unsettling thought, one that raises profound questions about identity, free will, and the nature of reality itself. Beyond the vastness of the multiverse lies the quantum realm, an area where the rules of classical physics break down and particles behave in ways that defy logic. Quantum mechanics governs the behavior of the smallest particles in the universe, such as electrons, photons, and quarks. In this strange domain, particles can exist in multiple states at once, a phenomenon known as superposition. This means that, at the quantum level, reality is not set in stone, but exists in a state of probabilities until observed. This bizarre behavior is central to phenomena like quantum entanglement, where two particles become so closely linked that a change in one instantly affects the other, even if they are light years apart. Quantum mechanics also introduces the concept of quantum fluctuations, which some scientists believe played a crucial role in the Big Bang itself. In the moments before the Big Bang, it's theorized that quantum fluctuations caused tiny variations in density, which then expanded during cosmic inflation, leading to the uneven distribution of matter we see in the universe today. These fluctuations might explain why galaxies and clusters formed in some regions and not others, giving rise to the intricate cosmic structure we observe on a large scale. Interestingly, the quantum world is also tied to our understanding of consciousness, one of the most mysterious phenomena known to science. While the link between quantum mechanics and consciousness is speculative, some researchers propose that consciousness might arise from quantum processes in the brain. This idea, though controversial, opens the door to a new perspective on what it means to be sentient beings in a universe governed by physical laws. Could consciousness itself be a fundamental property of the cosmos, interwoven with the fabric of space and time? While we are far from answering this question, it reminds us that the mysteries of the universe extend not only outward into space, but also inward into the depths of our own minds. Our exploration of these ideas is not merely theoretical. It has practical applications that could transform our future. Quantum mechanics, for example, is the foundation of technologies like quantum computing, which has the potential to revolutionize fields from cryptography to artificial intelligence. By harnessing the strange properties of quantum particles, researchers hope to build computers capable of performing calculations far beyond the reach of classical machines. Such advances could unlock new discoveries in fields like medicine, climate science, and materials engineering, reshaping the way we live and interact with the world. Meanwhile, the study of the universe's large-scale structure continues to reveal surprising connections between galaxies, clusters, and the unseen forces that bind them together. One of the most recent areas of interest is the study of cosmic filaments, the vast thread-like structures that connect galaxies and form the cosmic web. These filaments, composed primarily of dark matter, span hundreds of millions of light years and serve as the backbone of the universe's structure. They guide the movement of galaxies and influence the formation of clusters, revealing the intricate interplay between dark matter and visible matter on a cosmic scale. Dark matter, while invisible, exerts a gravitational pull that shapes the formation and movement of galaxies. But as mysterious as dark matter is, it's only half the puzzle. Dark energy, the force driving the universe's accelerated expansion, remains even more elusive. Some theories suggest that dark energy might be a property of space itself, an intrinsic energy that grows stronger as the universe expands. Others propose that dark energy could be the result of interactions between our universe and other dimensions. Understanding dark energy could be the key to predicting the ultimate fate of the universe, whether it will continue to expand forever, collapse in on itself, or reach a steady state. As we strive to uncover the secrets of dark matter and dark energy, we are reminded of the limitations of our current understanding. The standard model of physics, while successful in describing the behavior of particles and forces, cannot fully explain the nature of these mysterious substances. This has led scientists to propose new theories, such as string theory, which suggests that particles are not points but rather tiny, vibrating strings of energy. String theory also introduces the concept of extra dimensions, which could help explain why gravity behaves differently from other forces and why the universe appears to be expanding at an accelerated rate. Despite the challenges, each discovery brings us closer to a more complete picture of the universe. The journey from the Big Bang to the present day has been one of continuous exploration and revelation. We have gone from a single point of unimaginable energy to a universe filled with stars, planets, and galaxies, each a testament to the complexity and wonder of creation. Every star that shines, every galaxy that spins, and every particle that vibrates is a part of this grand cosmic symphony, a reminder of the profound interconnectedness of all things. Our quest to understand the cosmos is a reflection of our desire to understand ourselves. As we look out into the vastness of space, we also look inward, seeking answers to the questions that have driven humanity for millennia. Who are we? Why are we here? What is our place in this vast, ancient universe? The Big Bang may have marked the beginning of space and time, but it also ignited a journey of discovery that continues to this day, a journey that transcends the boundaries of science, philosophy, and imagination. The story of the Big Bang and the universe it created is not just a story of particles and forces. It's a story of mystery, beauty, and wonder. It's a story that invites us to explore, to question, and to dream. It reminds us that, no matter how vast and complex the cosmos may seem, we are all part of something extraordinary, a universe that began in a flash of light and energy and continues to evolve, creating and reshaping itself with every passing moment. As we stand on the edge of this cosmic ocean, looking out into the depths of space and time, we find ourselves both humbled and inspired, ready to take the next step in our journey to uncover the secrets of existence. As we move forward in our journey through the cosmos, we come face to face with the enigma of time itself. Time is one of the most fundamental aspects of our experience, yet it behaves in ways that challenge our intuition. In the vast stretches of space, time can bend, stretch, and even seem to stand still, revealing a universe that defies straightforward comprehension. This strange relationship between space and time is woven into the very fabric of the universe and is a direct consequence of the Big Bang. Einstein's theory of general relativity showed us that space and time are not separate entities. They are interconnected, forming a four-dimensional continuum known as space-time. Massive objects, such as stars and black holes, warp this fabric, creating gravitational wells that affect the flow of time. Near a massive object, time passes more slowly compared to regions with less gravitational influence. This effect, known as time dilation, is not just theoretical. It has been confirmed through experiments and even affects technology we use every day, like GPS satellites, which account for time dilation to maintain precise positioning. The concept of time dilation leads us to one of the most captivating phenomena in the cosmos: black holes. At the event horizon of a black hole, gravity becomes so intense that time itself appears to slow to a standstill. For an observer watching an object fall into a black hole, it would seem as though the object never actually crosses the event horizon. Instead, it would appear frozen in time. For the object itself, however, time continues normally, and it crosses the event horizon without experiencing any unusual change. This paradox is one of the many ways black holes push the boundaries of our understanding, revealing the strange and intricate relationship between time and gravity. In the realm of black holes, we also encounter one of the most profound mysteries of physics: the singularity. At the center of a black hole lies a point of infinite density, where space and time are compressed to an unimaginable extent. Here, the laws of physics as we know them break down, and our current understanding cannot describe what happens. Some scientists believe that the singularity of a black hole may hold clues to the conditions of the Big Bang, as both involve extremes of density and energy. Studying black holes may therefore help us understand the origins of the universe and the fundamental nature of reality. Beyond black holes, time takes on other unusual forms in the universe's early history. During the period of cosmic inflation, when the universe expanded at an exponential rate, time may have flowed in a manner we can barely comprehend. In this brief moment, the universe grew from a subatomic size to a macroscopic scale, faster than the speed of light. The mechanisms driving inflation remain largely unknown, but this event set the stage for the development of galaxies, stars, and planets, embedding a directional arrow into time itself. This arrow of time is an intriguing concept in physics. While the fundamental laws of physics are symmetrical, meaning they work the same way forward and backward, the universe seems to have a preferred direction of time, from the past to the future. This flow of time is closely linked to the concept of entropy, the measure of disorder in a system. According to the second law of thermodynamics, entropy tends to increase over time, meaning the universe becomes more disordered. This increase in entropy is what gives time its forward direction, distinguishing the past from the future and shaping the evolution of the cosmos. Time, as it turns out, is not a single, universal entity. It can vary depending on factors such as speed and gravity. This concept is central to the phenomenon of time travel, which, while still science fiction, is theoretically possible within the framework of relativity. Traveling at speeds close to the speed of light, for example, could allow an astronaut to experience time more slowly than someone on Earth, effectively allowing them to travel into the future. Wormholes, theoretical tunnels through space-time, are another potential pathway for time travel, although they remain speculative and unproven. These possibilities remind us of the strange and flexible nature of time, revealing a universe where the boundaries of past, present, and future may not be as fixed as they appear. As we continue our exploration, we are confronted by a final, haunting question: what will happen to time at the end of the universe? If the universe continues to expand indefinitely, it may reach a state known as heat death, where all energy is evenly distributed and no work can be done. In this scenario, the universe would reach maximum entropy, and time, as we understand it, would cease to have meaning. There would be no more events, No more change, only a static, lifeless cosmos. Alternatively, if the universe were to collapse back in on itself in a big crunch, time might reverse or cease altogether, bringing the story of the cosmos full circle. These concepts challenge our understanding and provoke us to think about our own place within this vast, time-bound universe. We are creatures of time, experiencing it in a linear fashion, bound to its arrow from birth to death. Yet the cosmos offers glimpses of a more fluid, complex relationship with time, one that suggests we may only be scratching the surface of a deeper reality. This journey through the mysteries of time and space invites us to consider the fleeting nature of our existence within the larger tapestry of the cosmos. The stars we see in the night sky are, in many cases, relics from the past, their light taking thousands, millions, or even billions of years to reach us. When we look up, we are seeing a cosmic history book, a record of events that have already happened. The light from some of these stars may have started its journey long before Earth even formed, carrying with it the stories of worlds and epochs that have since vanished into the cosmic past. At the same time, our exploration of time challenges us to consider our future. As we understand more about cosmic evolution, we gain insight into the potential futures of Earth, our solar system, and the universe itself. Studying the life cycles of stars, for example, gives us clues about the ultimate fate of our sun and the conditions that might affect life on Earth in billions of years. The fact that we can even attempt to understand these cycles is a testament to the progress of human thought, our ability to transcend the boundaries of our immediate experience and think on cosmic scales. In the end, our journey through time and space is not just about understanding the mechanics of the universe, but also about understanding ourselves. We are not separate from the cosmos. We are products of it, shaped by its laws and cycles. The atoms in our bodies were forged in the hearts of ancient stars, and the energy that sustains us is a part of the same energy that drives the universe forward. In this sense, we are both observers of and participants in the cosmic story, connected to the universe in ways that science is only beginning to unravel. The Big Bang, black holes, cosmic inflation, and the mysteries of time all serve as chapters in a story that is still unfolding. Each discovery opens new doors and raises new questions, reminding us that the universe is a place of endless wonder and possibility. Our exploration of the cosmos is more than a scientific endeavor. It is a journey of human curiosity, driven by a desire to understand the nature of existence itself. As we stand on the edge of what we know, gazing into the unknown, we are reminded that the universe is not a cold, empty void, but a dynamic, interconnected web of life, energy, and potential. We are part of this grand tapestry, bound to it by forces we are only beginning to comprehend. The mysteries of time, space, and existence call us to keep exploring, to keep asking questions, and to never stop seeking the answers that lie beyond the stars. In this pursuit, we find not just knowledge but a deeper sense of belonging, a recognition that in the vast expanse of the cosmos, we are truly home. As we continue our voyage through the cosmos, we encounter a realm of mysteries and possibilities that extend beyond even our boldest imaginations. The story of the universe is not only about the physical structures we observe, but also about the enigmatic forces and particles that shape and sustain everything we see, and much that we can't. Dark matter and dark energy, which together comprise roughly 95% of the universe, remain some of the most elusive components of existence, challenging us to rethink the nature of reality itself. Dark matter, though invisible, is detectable by its gravitational influence on visible matter. Without it, galaxies would not hold together, and clusters would not form in the intricate cosmic web we observe. Dark matter forms the hidden scaffolding upon which galaxies are built, shaping the universe in ways we are only beginning to comprehend. Yet we cannot see or touch dark matter, and despite decades of research, we have yet to identify exactly what it is. Some theories suggest that dark matter consists of undiscovered particles that interact very weakly with normal matter, while others propose that it could be evidence of phenomena that exist beyond the standard model of physics. It's a profound puzzle that keeps scientists searching, hoping to understand the role dark matter plays in the cosmic drama. Dark energy, is an even greater mystery. First discovered in the late 20th century, dark energy is thought to be the force responsible for the accelerated expansion of the universe. Unlike dark matter, which clumps and binds, dark energy seems to work in opposition to gravity, pushing galaxies apart. The nature of dark energy is so mysterious that it has led some physicists to speculate about the existence of a cosmological constant, an intrinsic energy of space itself, a sort of invisible force that increases as space expands. Others wonder if dark energy could represent a deeper, hidden layer of physics, potentially revealing unknown dimensions or even interactions with parallel universes. The implications are staggering and suggest that what we perceive as reality may be only a small fraction of a much larger, interconnected cosmos. The hunt for dark matter and dark energy has inspired ambitious experiments on Earth and in space, from particle detectors deep underground to satellite telescopes mapping the universe. These experiments are part of a growing field called astroparticle physics, which merges the study of cosmic phenomena with the principles of particle physics. The Large Hadron Collider, LHC, in Switzerland, for instance, is probing the smallest particles known to science, searching for clues about the building blocks of dark matter. At the same time, telescopes like the Dark Energy Survey are studying distant galaxies to measure the effects of dark energy on cosmic expansion. Each of these efforts brings us closer to understanding these invisible forces that shape the universe, though their secrets remain tantalizingly out of reach. In addition to dark matter and dark energy, scientists are exploring another fundamental question: what happened in the moments immediately following the Big Bang? The first few seconds of the universe's existence remain one of the greatest mysteries of all. During this period, the universe was a seething plasma of particles and energy, a chaotic realm where temperatures and densities were unimaginably high. In these early moments, the fundamental forces of nature, gravity, electromagnetism, and the nuclear forces, were thought to be unified into a single force. As the universe cooled, these forces separated, a process known as symmetry breaking. Understanding these early moments is key to unlocking the nature of the fundamental forces and could even provide clues about the ultimate fate of the cosmos. One approach to understanding these early conditions involves studying particles like neutrinos, nearly massless particles that barely interact with matter. Neutrinos are thought to have been produced in huge quantities during the first seconds of the Big Bang and continue to permeate the universe. By studying neutrinos and other elementary particles, scientists hope to gain insight into the conditions of the early universe and perhaps even glimpse the nature of the unified force that existed before symmetry breaking. This research could also shed light on antimatter, the counterpart to ordinary matter, which mysteriously disappeared in the early universe, leaving the cosmos we observe dominated by matter. Antimatter, though it behaves like regular matter, has opposite charges. When matter and antimatter meet, they annihilate each other in a burst of energy. According to current theories, the Big Bang should have created equal amounts of matter and antimatter. However, the universe is almost entirely composed of matter, with antimatter virtually absent. This asymmetry remains one of the greatest unsolved questions in cosmology and particle physics. Why did matter survive while antimatter disappeared? Discovering the answer could rewrite our understanding of the early universe and provide new perspectives on the nature of existence. Another frontier in our quest to understand the universe is the search for gravitational waves. Ripples in space-time caused by the acceleration of massive objects, like colliding black holes or merging neutron stars. Predicted by Einstein's theory of general relativity and first detected in 2015, gravitational waves have opened an entirely new way of observing the cosmos. Unlike light, which can be absorbed or blocked by matter, gravitational waves pass through objects unimpeded, providing a pristine view of events billions of light-years away. These waves offer a unique glimpse into cataclysmic events and allow us to probe the universe in ways previously thought impossible. With each new detection, we gather more data about the nature of gravity and the extreme environments where these waves are born. Gravitational waves also hold the potential to reveal what lies beyond the observable universe. While we can only see as far as light has traveled since the Big Bang, Gravitational waves might allow us to detect signals from events that occurred even earlier, giving us a glimpse into the hidden past of the cosmos. Some researchers speculate that gravitational waves could reveal evidence of cosmic inflation or even hint at the presence of parallel universes, providing tantalizing clues about the universe's origins. In our search for answers, we are also venturing into the realm of high-energy astrophysics, studying cosmic rays and gamma rays, some of the most energetic particles in the universe. These particles originate from extreme events, such as supernovae and black hole jets, and can reach Earth at nearly the speed of light. By studying these high-energy particles, scientists hope to uncover the processes that drive the most violent events in the cosmos and understand how particles are accelerated to such incredible speeds. Observatories like the Fermi Gamma Ray Space Telescope and the Pierre Auger Observatory are dedicated to tracking these elusive particles, each a tiny messenger from the farthest reaches of the universe. Through all of these efforts, we are beginning to assemble a grand picture of the universe, a place that is far more complex, interconnected, and mysterious than we ever imagined. The more we discover, the more we realize how much remains unknown. Every answer raises new questions, pushing us to rethink our assumptions and expand our horizons. Our understanding of the cosmos is constantly evolving, shaped by each new piece of the puzzle we uncover. But the ultimate questions remain. What is the true nature of reality? Are there dimensions or realms beyond what we can perceive? And how do the forces that govern the cosmos relate to our own existence? These questions lie at the heart of our exploration, urging us to look deeper, reach further, and question everything we thought we knew. The story of the universe is a story without an ending. It's a tale of creation, transformation, and discovery that spans billions of years and encompasses everything from the tiniest particles to the largest galaxies. The universe is constantly changing, evolving in ways we are only beginning to understand. Our place within this cosmic tapestry is both humbling and inspiring, reminding us of the power of curiosity and the unbreakable connection between humanity and the stars. As we look to the future, we know that the journey is far from over. The mysteries of dark matter, dark energy, and the origins of time and space continue to call us forward. The universe beckons us to explore, to question, and to dream. And as long as we have the courage to follow this call, we will continue to uncover the wonders of the cosmos, one discovery at a time, each revelation bringing us closer to understanding the magnificent, awe-inspiring universe we call home. As we stand on the brink of new cosmic revelations, our understanding of the universe only deepens our sense of wonder and the vastness of the unknown. Each discovery we make pushes the boundaries of human knowledge and invites us to rethink not only our place in the cosmos, but also the very nature of reality itself. In recent years, the development of advanced technologies and international collaborations have led to unprecedented progress, giving rise to new projects that promise to transform our view of the universe even further. One of the most exciting developments in astronomy is the advent of next-generation telescopes. The James Webb Space Telescope, launched with great anticipation, represents a leap forward in our ability to peer into the distant reaches of the universe. With its powerful infrared capabilities, the James Webb can observe galaxies as they were billions of years ago, near the very beginning of cosmic history. It's expected to reveal the birthplaces of stars and planets in incredible detail and to provide clues about the formation of galaxies in the early universe. In essence, it's a time machine, allowing us to look back across epochs and witness events that shaped the cosmos. Another ambitious project, the extremely large telescope, YELT, is under construction in the Atacama Desert in Chile. Once completed, it will be the world's largest optical telescope, with a mirror nearly 40 meters in diameter. This powerful instrument will give scientists the ability to study the atmospheres of exoplanets in detail, potentially detecting signs of life beyond Earth. By analyzing the composition of distant planets' atmospheres, we may be able to identify biosignatures, molecules associated with biological processes, offering tantalizing hints about the possibility of extraterrestrial life. The YELT, along with other upcoming telescopes, marks the beginning of a new era in which we can search for life beyond our solar system with unprecedented precision. In addition to telescopes, missions to the outer reaches of our own solar system are shedding light on worlds that were once beyond our reach. The New Horizons mission, which gave us our first close-up look at Pluto, has continued its journey into the Kuiper Belt, a region of icy bodies that holds clues about the early solar system. Meanwhile, missions like the Europa Clipper are being prepared to explore the icy moons of Jupiter and Saturn, which may harbor subsurface oceans beneath their frozen crusts. These moons, including Europa and Enceladus, are some of the most promising places to search for microbial life within our solar system, as they have conditions that may be similar to those on Earth. The search for extraterrestrial life, once limited to distant star systems, now includes a focus on these hidden oceans. If life exists beneath the ice on moons like Europa, it would suggest that life can emerge and thrive in environments far different from those on Earth. Such a discovery would have profound implications, showing that life might be far more common and resilient than we ever imagined. It would mean that the cosmos could be teeming with life in forms and places we have yet to envision. Another groundbreaking project is the Laser Interferometer Space Antenna, LISA, a space-based gravitational wave observatory set to launch in the 2030s. LISA will be capable of detecting gravitational waves from events even more distant and massive than those observed by Earth-based detectors like LIGO. By capturing these signals, LISA will allow us to observe mergers between supermassive black holes and other cataclysmic events that occurred in the early universe. Gravitational waves provide a unique way to study cosmic phenomena invisible to traditional telescopes, offering insight into the structure and behavior of black holes, neutron stars, and even the possible existence of primordial black holes formed shortly after the Big Bang. The study of primordial black holes is particularly intriguing because they could offer clues about dark matter. Some theories suggest that these ancient black holes might make up a significant portion of dark matter, the elusive substance that exerts gravitational influence but does not emit light. If primordial black holes are indeed a component of dark matter, their discovery would be a major breakthrough, helping to solve one of the most perplexing mysteries in cosmology. Observing these objects through gravitational waves could reveal their presence and distribution, helping us understand how they influence the formation of galaxies and the large-scale structure of the universe. Parallel to these cosmic pursuits, the development of quantum computing and artificial intelligence is revolutionizing our ability to process and analyze vast amounts of astronomical data. Quantum computers, which harness the strange properties of quantum mechanics, have the potential to solve problems that are currently beyond the reach of classical computers. These machines could be used to simulate complex cosmic events, such as galaxy formation or the behavior of black holes, with a level of detail and accuracy previously unimaginable. Artificial intelligence, meanwhile, is enabling astronomers to sift through massive data sets, identifying patterns and anomalies that would be impossible for human researchers to detect. With AI's help, discoveries that once took years to achieve can now be made in a fraction of the time, accelerating our journey into the unknown. The potential of these technologies is transformative, but they also bring new challenges and ethical questions. As we continue to probe the universe and possibly discover signs of life beyond Earth, we must consider the implications of such a finding. How would humanity react to the discovery of extraterrestrial life, even if only microbial? And if intelligent life were found, what would it mean for our understanding of consciousness, morality, and our place in the universe? These questions remind us that exploration is not just a scientific endeavor, but a philosophical and existential one, raising profound questions about our identity and purpose. The search for answers also drives us to reflect on the fragility and beauty of our own world. As we discover more about the vastness and diversity of the universe, Earth stands out as an oasis, a rare gem of life in an expanse of seemingly uninhabitable worlds. The more we learn about other planets, the more precious our own world appears, emphasizing the importance of preserving and cherishing the delicate balance that sustains life here. Understanding our planet's place in the cosmic web not only deepens our connection to the universe, but also strengthens our responsibility to protect it for future generations. Looking ahead, the future of cosmic exploration is boundless. From interstellar travel to the search for alien life, from understanding dark matter to uncovering the origins of consciousness, humanity's journey has only just begun. We are a species driven by curiosity, always reaching beyond our grasp, compelled by a desire to know more, to see further, and to understand the mysteries of existence. This drive has brought us from the early days of stargazing to the exploration of planets and galaxies far beyond our own. The story of the universe, from the Big Bang to the present day, is an unfolding tale of wonder and discovery. Each new chapter we uncover is both an answer and an invitation to keep searching, to keep asking questions, and to never lose sight of the marvels that await us. As we continue to explore, we carry the legacy of those who looked up at the stars before us, fueled by the same insatiable curiosity and awe for the cosmos. We are part of a universe that is both familiar and strange, both visible and hidden, a place of known laws and unsolved mysteries. The more we uncover, the more we realize how much remains to be discovered. But it is this very mystery that gives meaning to our journey, that makes each new discovery feel like the opening of a door to a new frontier. Our exploration of the cosmos is not just a search for knowledge. It is a celebration of the boundless potential of human imagination and a reminder of the infinite possibilities that lie ahead. As we gaze into the depths of space and time, we are reminded that our story is woven into the story of the universe itself. We are stardust, shaped by the same forces that govern galaxies, bound to the same cosmic web that holds the stars. And while our lives may be brief compared to the age of the universe, our journey of discovery endures, connecting us across generations, across galaxies, and across the timeless fabric of existence. We are explorers, searching not only for the secrets of the stars, but for a deeper understanding of ourselves and our place in the cosmos. The universe is our home, a vast, mysterious, and awe-inspiring domain that invites us to keep moving forward, to keep looking upward, and to never stop wondering at the beauty and mystery of it all. As we peer further into the cosmic abyss, the questions that arise reveal not just the intricacies of distant galaxies and phenomena, but profound insights into the nature of existence itself. We stand at a unique point in human history where the boundaries between science and philosophy, observation and imagination, are more intertwined than ever. The cosmos beckons us not only to look outward, but to reflect inward, to understand that exploring the universe is, in many ways, an exploration of our own humanity. One of the most tantalizing questions in modern astronomy is the nature of consciousness within the grand tapestry of the cosmos. Our awareness of the universe, our ability to question, explore, and even comprehend such vastness, stands as one of the greatest mysteries of all. How did a collection of atoms, born in the hearts of stars, coalesce into beings capable of self-reflection? This enigma draws scientists, philosophers, and thinkers alike to consider the possibility that consciousness itself may be a fundamental part of the universe, as essential and ubiquitous as gravity or light. Some theories suggest that consciousness could arise from quantum processes within the brain, potentially linking human awareness to the fabric of space-time in ways we have yet to fully understand. Such questions push us to consider whether consciousness might exist elsewhere in the universe. As we search for signs of extraterrestrial life, the concept of intelligence and awareness beyond Earth is no longer confined to science fiction, but lies within the realm of possibility. Could other civilizations be looking back at us from across the stars, driven by the same curiosity and wonder? Might their concept of reality and existence be shaped by entirely different environments and laws of physics? Each exoplanet we discover, each signal we listen for, holds the potential to reveal not only other forms of life, but other ways of perceiving and understanding the universe. Parallel to these philosophical ponderings, our technological advancements are pushing the limits of human reach. With the development of new propulsion technologies and advancements in robotics, the possibility of interstellar travel, once a distant dream, now seems within the grasp of future generations. Concepts like solar sails, which harness the energy of light to propel spacecraft, and nuclear fusion propulsion, which promises far greater speeds than current technology, are beginning to materialize. These advancements could one day allow humanity to reach neighboring star systems, with destinations such as Proxima Centauri b, an Earth-like exoplanet just over 4 light-years away, becoming potential targets for exploration. The idea of interstellar travel introduces questions about the future of humanity and what it might mean to become an interplanetary or even interstellar species. If we were to settle other planets or explore distant stars, how would our identity as Earthlings change? Would we see ourselves as explorers, forever venturing into the unknown, or as caretakers of new worlds, responsible for preserving the environments we encounter? Colonizing other planets, especially Mars, has become a tangible goal, with plans for human missions in the coming decades. Mars could be the first step, but our sights are set on the stars, and each advancement in space exploration brings us closer to a reality where humanity might live among the stars. Yet, in our rush to explore, we must also confront the ethical considerations of cosmic expansion. What responsibilities do we bear toward any life, microbial or intelligent, that we might encounter? What ethical frameworks should guide our interactions with ecosystems and atmospheres that have developed independently for billions of years? The notion of cosmic ethics is gaining traction, urging us to approach space exploration with humility and respect. As stewards of our own planet, we are beginning to recognize the importance of preserving not only Earth's natural beauty and ecosystems, but also the untouched realms of other worlds. While we look outward, our journey through the cosmos also inspires us to look back at our own world with renewed appreciation. Earth, seen from space, appears as a fragile blue sphere suspended in the vastness of the universe, a reminder of the rarity and beauty of life. This perspective, often called the overview effect, is experienced by astronauts who, upon seeing Earth from above, develop a profound sense of connection to humanity and a deep concern for the planet's well-being. This shift in perspective underscores the importance of taking responsibility for our environment and cherishing the planet that has nurtured us. At the same time, the exploration of space fosters a sense of unity across cultures and nations. Space missions require cooperation on a global scale, bringing together scientists, engineers, and leaders from around the world to work toward common goals. The International Space Station is a prime example of this collaboration, where astronauts from different countries live and work side by side, conducting research that benefits all of humanity. This spirit of cooperation in space exploration serves as a model for addressing global challenges here on Earth, reminding us that we are all part of a single human family. In this shared quest for knowledge, the boundaries between nations and cultures begin to dissolve, replaced by a collective identity as explorers of the universe. This shift in perspective challenges us to view humanity's future not as individual nations or societies, but as a unified civilization, reaching outward to the stars. The challenges of space exploration demand that we transcend our differences, recognizing that the pursuit of knowledge, the drive to understand, and the will to explore are universal values that unite us all. As we continue our journey, we are drawn to the ultimate question: what is the purpose of the universe, and what role do we play within it? Are we simply observers, existing for a brief moment in the cosmic timeline, or is there a deeper significance to our existence? Philosophers and scientists alike ponder these questions, each new discovery adding layers of complexity to our understanding of reality. Some propose that the universe may be a vast network of interconnected systems, each contributing to a grand, self-organizing whole. Others wonder if consciousness and intelligence are means through which the universe becomes aware of itself, with humanity serving as one expression of this cosmic self-reflection. These questions lead us to the realm of metaphysics, where science and spirituality often intersect. As we uncover the mechanics of the universe, we also touch upon questions that science alone may never fully answer. The nature of consciousness, the meaning of life, and the origins of existence all point to mysteries that invite both scientific inquiry and philosophical reflection. In the end, the journey to understand the cosmos may lead us back to ourselves, revealing that the greatest mysteries lie not only in the stars but within our own minds and hearts. Each step forward in our cosmic exploration brings us closer to a more comprehensive understanding of existence, yet it also serves as a reminder of the limits of human knowledge. We are finite beings in an infinite cosmos, capable of great discoveries, but also limited by our perception and understanding. The vastness of the universe humbles us, yet it also inspires us, urging us to continue exploring, learning, and growing. In the grand scheme, the universe may not need humanity, but humanity certainly needs the universe. The cosmos gives us perspective, wonder, and purpose. It challenges us to push beyond the boundaries of what we know, to dream bigger, and to imagine worlds and possibilities beyond our current understanding. The universe is not just a backdrop to our lives. It is the very stage upon which our story unfolds, the canvas upon which we paint the narrative of human existence. Our journey through the cosmos is still in its infancy, and the discoveries we make in the coming years and centuries will likely redefine our understanding of reality many times over. Yet, no matter how far we venture, the universe will always hold more mysteries, more questions, and more wonders. It is an endless frontier, a source of endless inspiration, and as long as we have the will to explore, the story of humanity and the stars will continue to unfold. As we gaze into the depths of space and contemplate the mysteries that lie ahead, we carry with us the legacy of those who first looked up at the stars with wonder. We are part of a cosmic lineage, a lineage of explorers and dreamers, each generation passing on the torch of curiosity and knowledge to the next. And so, we continue, knowing that the universe, in all its vastness and mystery, awaits us. The stars are calling, and our journey has only just begun. As we press onward in our cosmic exploration, each revelation we uncover draws us deeper into the complexities and paradoxes of existence. The universe, once thought to be a static, unchanging void, reveals itself as a dynamic, ever-evolving structure where even the most fundamental truths are open to re-examination. With every new insight, we find ourselves standing on the threshold of ideas that challenge the very fabric of what we know, compelling us to question our role within this grand design. One of the most intriguing puzzles lies in the nature of reality itself. Advances in physics, especially in the realms of quantum mechanics and cosmology, have introduced concepts that push the boundaries of conventional thought. The theory of quantum mechanics tells us that at the smallest scales, particles do not behave as solid objects but rather as waves of probability, existing in multiple states simultaneously until observed. This phenomenon, known as superposition, suggests that reality is not as fixed or as concrete as it appears. Instead, it is a fluid, constantly shifting tapestry shaped by observation and interaction. This strange behavior leads to the concept of quantum entanglement, in which particles separated by vast distances become inexplicably connected, influencing each other's states instantaneously, regardless of distance. The implications are profound, challenging our understanding of space, time, and causality. How can two particles, light years apart, communicate faster than the speed of light? This spooky action at a distance, as Einstein famously called it, suggests that the universe operates on principles that transcend our current grasp of physics, hinting at hidden layers of reality interconnected in ways we have yet to decipher. The mysteries of quantum mechanics open the door to theories of parallel worlds and alternate dimensions. According to the many worlds interpretation, every possible outcome of a quantum event actually occurs, each in its own distinct universe. This theory implies an infinite multiverse, where countless versions of ourselves might exist, each experiencing a different reality. The multiverse concept suggests that our universe may be just one of an unending sea of realities, each governed by its own unique laws of physics. This idea transforms our understanding of existence, inviting us to ponder whether our reality is merely one thread in an endless cosmic fabric. Meanwhile, the realm of black holes introduces its own set of enigmas. Black holes are not simply cosmic vacuums that devour everything in their path. They are gateways into some of the deepest mysteries of physics. When matter crosses the event horizon, it is drawn toward the singularity, a point of infinite density where the known laws of physics break down. Some physicists speculate that black holes might contain wormholes, theoretical passages through space-time that could potentially link different parts of the universe, or even different universes. While still speculative, the existence of wormholes raises the tantalizing possibility of interstellar shortcuts or even travel between parallel worlds, offering humanity a way to transcend the limitations of space and time. The study of black holes has also led to one of the most perplexing paradoxes in physics, the information paradox. According to quantum mechanics, information cannot be destroyed. However, anything that falls into a black hole seems to vanish from our observable universe, lost forever behind the event horizon. This conundrum pits two pillars of physics, quantum mechanics and general relativity, against each other, suggesting that our understanding of reality is incomplete. Some scientists propose that information is not truly lost, but rather encoded on the surface of the black hole in a way we do not yet understand. This idea has led to the holographic principle, a theory suggesting that our three-dimensional universe might actually be a projection of information encoded on a two-dimensional boundary. In essence, reality as we perceive it could be akin to a cosmic hologram, a three-dimensional illusion created by information on a distant surface. The holographic principle, if proven, would revolutionize our understanding of the universe, suggesting that space and time are emergent properties rather than fundamental aspects of reality. This theory hints at the possibility that everything we experience, from the smallest particles to the grandest galaxies, could be part of an intricate, interconnected network, a hologram woven from information at the deepest level. It's a concept that blurs the line between physics and philosophy, raising profound questions about the nature of existence, perception, and even consciousness itself. Consciousness, in particular, emerges as one of the greatest enigmas in this cosmic puzzle. While science has made remarkable strides in understanding the brain and its functions, the subjective experience of awareness, our ability to think, feel, and perceive the world, remains largely unexplained. Some researchers propose that consciousness might be a fundamental property of the universe, like gravity or electromagnetism, rather than a byproduct of biological processes. This perspective, known as panpsychism, suggests that consciousness could be embedded in the fabric of reality, manifesting in varying degrees across all matter. While controversial, this idea offers a fascinating lens through which to view the interconnectedness of all things, implying that awareness is not confined to humans but may be a cosmic phenomenon. The study of consciousness also intersects with our exploration of artificial intelligence and machine learning. As AI systems become more advanced, they begin to perform tasks that once seemed exclusive to human intelligence, such as language comprehension, problem-solving, and even creativity. This raises questions about the nature of thought and awareness. Could an advanced AI ever truly be conscious? Or is consciousness something uniquely tied to biological life? The question challenges us to define what it means to be aware and forces us to confront the boundaries of human understanding. The search for consciousness, whether in ourselves, in machines, or potentially in extraterrestrial life, leads us back to fundamental questions about the nature of existence and the possibility that awareness is woven into the very fabric of the universe. While these questions might seem abstract or theoretical, they hold practical implications for our future. If we discover that consciousness is a universal property, it could reshape our ethical frameworks, influencing how we approach artificial intelligence, animal rights, and environmental conservation. Such a realization could inspire a greater sense of unity, fostering a recognition that all beings are part of a shared cosmic consciousness. This perspective would redefine our relationship with the natural world, encouraging us to treat all forms of life with respect and reverence, seeing them as interconnected expressions of the same cosmic essence. As we look toward the future, our exploration of the cosmos also brings us closer to a deeper understanding of ourselves. The questions we ask about the universe, its origins, its nature, and its ultimate fate mirror the questions we ask about our own lives. What is our purpose? Why are we here? Are we part of something larger, something beyond our individual existence? The journey to understand the universe is, in many ways, a journey to understand humanity's place within it, a quest to discover meaning in the vastness of the cosmos. And yet, for all our advancements and discoveries, we are reminded that the universe is ultimately unknowable in its entirety. Each answer we find opens the door to new mysteries, and the horizon of knowledge continues to expand before us. The universe is a boundless frontier, an infinite mystery that humbles us, reminding us of our limitations and inspiring us to keep reaching further. Our exploration of the cosmos is both a scientific endeavor and a spiritual journey, a quest to understand not only the mechanics of the universe, but also the profound beauty and complexity that underlie it. In this endless pursuit, we come to realize that the mysteries of the universe are not obstacles to be conquered, but invitations to wonder. The unknown is not something to be feared or dismissed. It is a realm of possibility, a reminder that we are part of a universe that is alive with potential. Each discovery is a step closer to understanding the whole, yet the whole is always beyond reach, a reminder that the universe is, at its core, an endless source of awe. The universe does not owe us answers. It exists in its vastness and mystery, indifferent to our curiosity, yet open to exploration. Our role is not necessarily to solve all of its mysteries, but to engage with them, to marvel at the beauty of existence, and to find meaning within the journey itself. As we gaze at the stars, we are not merely looking out into space. We are looking into the depths of our own souls, seeking connection, purpose, and understanding in the infinite expanse. This journey, filled with wonder and discovery, binds us together as a species, reminding us that we are all travelers in a cosmic voyage, united by our shared origin in the stardust of the universe. We are here, in this moment, part of something far greater than ourselves, and that knowledge alone is a gift. So, as we continue to explore, let us carry with us a sense of humility, curiosity, and reverence for the universe and our place within it. The cosmos calls to us, and we answer, not for the destination, but for the journey, for the pursuit of knowledge, and for the endless wonder that lies ahead. As our journey into the cosmos unfolds, the questions deepen, leading us into realms where the boundaries between science, philosophy, and even mysticism blur. The universe, with all its vastness and complexity, begins to resemble a living entity, constantly evolving and transforming, with each discovery hinting at a larger, interconnected order. The more we probe the mysteries of existence, the more we sense that our quest to understand the cosmos might ultimately be a quest to understand our own nature, our purpose, and our connection to the universe itself. One of the most profound realizations in modern cosmology is that the universe is not static but dynamic, in a perpetual state of motion and change. The concept of an expanding universe, once revolutionary, is now foundational to our understanding of cosmic history. Yet this expansion is not merely a uniform stretching of space. It is filled with pockets of creation and destruction, where galaxies collide, stars are born, and black holes devour. It is a process that mirrors life itself, a constant cycle of beginnings and endings, driven by forces both visible and invisible. The role of dark energy in driving this expansion introduces a sense of acceleration, a cosmic stretching that pushes galaxies apart faster and faster as time goes on. The discovery of this force has shifted our understanding of the universe's future, suggesting a cosmos that could expand indefinitely. In such a scenario, we envision a distant future where galaxies drift so far apart that they become isolated islands, eventually unreachable and invisible to one another. Stars would fade and die, and the universe could end in a big freeze, a silent, cold expanse where matter itself might decay, leaving only a thin, ghostly remnant of existence. However, the possibility of a big freeze is not the only hypothesis regarding the ultimate fate of the universe. Some scientists propose the idea of a big rip, a scenario in which dark energy becomes so dominant that it eventually tears apart galaxies, stars, planets, and even the very atoms that make up all matter. This dramatic ending would represent not just the death of individual structures within the universe, but the dissolution of the universe itself, a shattering of the very fabric of reality. It is a vision of cosmic mortality, a reminder that even the universe as a whole may have an end point. Yet another possibility is the Big Crunch, a theory suggesting that the expansion of the universe could eventually reverse, causing all matter to collapse back into a single point, perhaps triggering a new Big Bang and a new cycle of creation. This cyclical model hints at a universe with no definitive beginning or end, an eternal series of expansions and contractions, births and rebirths. In this view, the universe is like a cosmic heartbeat, pulsing through cycles of life, death, and renewal. Such a theory challenges our understanding of time, implying that the arrow of time itself could be cyclical, looping back on itself in an infinite dance of creation. These scenarios inspire us to contemplate the nature of time and its relationship to existence. While we experience time as a linear sequence, past, present, future, the universe suggests that time might be far more complex, perhaps even illusory. The concept of time as a dimension, intertwined with space, hints at possibilities where time may bend, fold, or even cease to exist. Some theories propose that time is an emergent property, arising from deeper, timeless laws that govern the universe. In this view, what we perceive as the flow of time is a reflection of changes in state, an outcome of the universe's fundamental structure rather than a fundamental aspect itself. The possibility of a timeless reality challenges us to rethink the way we experience existence. If time is not a fundamental property, but rather an emergent one, then perhaps our experience of temporality, our sense of past, present, and future, is limited by our perception. This idea brings us closer to ancient philosophical perspectives that saw reality as a continuous, interconnected whole, where separations like past and future are constructs of the mind. Such perspectives echo in modern physics, where the boundaries between observer and observed, between time and timelessness, dissolve at the quantum level, suggesting a universe that is not merely out there, but one in which we are deeply, intrinsically involved. In this interconnected universe, consciousness itself becomes a profound mystery. What role does awareness play in shaping reality? If observation affects the state of particles at the quantum level, as suggested by the famous double-slit experiment, then might consciousness be woven into the very fabric of existence? Some researchers propose that consciousness could be a fundamental aspect of the universe, an intrinsic quality that pervades all matter. This idea, while speculative, invites us to consider that awareness and existence are not separate but entwined, that perhaps the universe is not just something we observe but something that observes itself through us and potentially through countless other conscious entities. The notion that consciousness could be a universal property leads to a profound shift in perspective. It suggests that we are not passive observers in a detached universe, but active participants in a cosmic web of awareness. In this view, every thought, every perception, and every experience contributes to the unfolding of reality. This perspective aligns with theories of interconnectedness, where every particle, every galaxy, and every mind is a thread in a vast, cosmic tapestry, each contributing to the larger story of existence. As we venture deeper into this mystery, we encounter questions that bridge science and spirituality. What if the universe is not just a collection of particles and forces, but a conscious entity in its own right, an organism of unimaginable scale and complexity? Such an idea is not entirely new. It resonates with ancient philosophies that saw the cosmos as a living, breathing whole. In these traditions, the universe is not merely a mechanical system, but a sacred, interconnected organism, where everything from the smallest atom to the largest galaxy is part of a unified consciousness. The exploration of these ideas reminds us that our understanding of the universe is still in its infancy. Each discovery brings us closer to the edge of what we know, yet beyond that edge lies an endless sea of the unknown. The universe, it seems, is boundless not only in space, but in the potential for meaning, inviting us to continually re-examine our assumptions and expand our horizons. This journey into the unknown is more than a pursuit of knowledge. It is a search for connection, a quest to find our place within the larger cosmic order. As we learn more about the universe, we also learn more about ourselves. We see that we are not isolated beings, but expressions of the universe, made from the same elements that fuel stars, bound by the same forces that govern galaxies, and driven by the same curiosity that defines the cosmos itself. In this light, our exploration of the cosmos takes on a new significance. It becomes a form of communion with the universe, a way of participating in the grand adventure of existence. The questions we ask about the nature of time, the role of consciousness, the structure of reality, are not just intellectual pursuits. They are acts of wonder, expressions of our deepest longing to understand the mystery of being. As we continue to explore, we are reminded that the journey itself is the destination. The universe may never fully reveal its secrets, but in seeking them, we uncover truths about our own nature, our potential, and our purpose. The cosmos is vast and incomprehensible, yet it is also intimate, woven into the very fabric of our existence. To explore it is to engage in a dialogue with the infinite, to reach across the boundaries of space and time, and to connect with something far greater than ourselves. The universe is a story of beginnings without endings, a story of beauty, mystery, and endless possibility. It is a story that invites us to participate, to imagine, and to dream. And as long as we keep asking questions, as long as we keep looking to the stars with wonder and curiosity, the story of the universe, and our place within it, will continue to unfold. The stars call to us, not as distant points of light, but as beacons of connection, reminders that we are part of a vast, cosmic family, bound together by the same forces, the same elements, and the same desire to understand. So, we press on, journeying ever deeper into the unknown, knowing that each step, each discovery, and each question brings us closer to the heart of the cosmos. And perhaps, in that journey, we will find that the answers we seek have been within us all along, waiting for us to realize that, in this vast and infinite universe, we are already home. As we venture further into the vast expanse of the universe, our understanding continues to evolve, and with it, our sense of wonder grows. Each discovery reveals not only new layers of complexity, but also a profound beauty that transcends explanation. The universe, it seems, is a cosmic symphony where forces, particles, and galaxies move in an intricate dance of harmony and chaos, creation and destruction. In this symphony, we are both the audience and a part of the orchestra, seeking to understand not only the notes and rhythms of existence, but also the meaning of the song itself. One of the most compelling aspects of this cosmic journey is the realization that we are composed of the same elements forged in the cores of stars. Every atom in our bodies, from the carbon in our cells to the iron in our blood, was formed in the heart of a dying star billions of years ago. This connection between life and the cosmos is not just poetic. It is a scientific reality that speaks to our deep, intrinsic relationship with the universe. We are, in every sense, stardust come to life, conscious fragments of the cosmos trying to understand ourselves. The story of the elements begins in the earliest moments after the Big Bang, when the universe was a hot, dense sea of particles. As it expanded and cooled, protons and neutrons combined to form hydrogen and helium, the simplest elements. These early elements would go on to fuel the first generation of stars, whose intense heat and pressure would forge heavier elements through nuclear fusion. When these massive stars reached the end of their lives, they exploded in supernovae, scattering these elements across space. Over billions of years, this process repeated, enriching the universe with the diverse array of elements that now make up planets, stars, and life itself. This stellar alchemy reminds us that creation is often born from destruction. The death of stars gives rise to the building blocks of life, a cycle of renewal that spans the cosmos. This understanding challenges us to view life and death not as opposites, but as complementary aspects of a continuous process. In the grand scheme, the universe is constantly recycling itself, turning dust into stars and stars into dust, a cosmic cycle that mirrors the cycles of life on Earth. Our journey into the cosmos also illuminates the delicate balance that makes life possible. Earth exists in a Goldilocks zone, a region around the sun where conditions are just right for liquid water to exist. This seemingly small detail is crucial, as water is essential for life as we know it. Yet, as we look to the stars, we realize that Earth's habitability is the result of countless factors that align in a delicate, almost improbable balance. From the size of our planet to the stability of our star, from the presence of a protective magnetic field to the cycles of our climate, Earth is a rare oasis in a universe that is, for the most part, hostile to life. This fine-tuning of the universe has led some scientists and philosophers to ponder whether there is a deeper purpose to existence. Why do the laws of physics seem so precisely calibrated to allow for the emergence of complex structures and, eventually, conscious beings? Some propose that our universe may be just one of many in a multiverse, with each universe having its own unique set of physical laws. In this view, we inhabit one of the rare universes where the conditions happen to align in such a way that life could emerge. Others suggest that the universe's fine-tuning may point to a deeper order, a principle or consciousness that underlies reality. While these ideas are speculative, they remind us that the universe is not only vast, but also filled with mysteries that extend beyond the reach of our current understanding. As we expand our exploration, we also confront the possibility that we are not alone. The discovery of exoplanets, planets orbiting stars beyond our solar system, has opened a new frontier in the search for life. With each new exoplanet discovered, especially those in habitable zones, we inch closer to answering one of humanity's most profound questions. Are we alone in the universe? The discovery of microbial life, or even intelligent life, elsewhere would not only transform our understanding of biology, but also challenge us to reconsider our place in the cosmos. Such a discovery would imply that life is a natural outcome of the universe's evolution, a phenomenon that arises wherever conditions are favorable. Yet, even in the absence of direct evidence of extraterrestrial life, the mere possibility expands our sense of the universe. It reminds us that our experience is not the only one, that other worlds may exist with their own histories, ecosystems, and perhaps civilizations. The search for life beyond Earth is, in many ways, a search for connection, a desire to find others in the vast, silent reaches of space who share our experience of wonder and curiosity. This quest for connection also inspires us to look inward, to understand the nature of life on Earth and the bonds that tie us to each other and to our planet. Earth, our home, is a rare and fragile world, and our exploration of the cosmos has highlighted its uniqueness. From the vantage point of space, we see Earth as a single, unified whole, free from the divisions and boundaries that separate us. This perspective, often experienced by astronauts and known as the overview effect, reminds us of our shared humanity and the responsibility we bear to care for our planet and each other. As we deepen our exploration of space, we are also reminded of the ethical questions that arise with our expanding reach. If we encounter life, even in its simplest forms, how should we approach it? Do we have a responsibility to protect other ecosystems as we strive to protect our own? The idea of cosmic stewardship is gaining traction, urging us to approach space exploration with a sense of humility and responsibility. Just as we recognize the importance of conserving Earth's environments, we may come to see the preservation of other worlds as part of our ethical duty as explorers of the cosmos. In this sense, our journey into space is not just about exploration. It is about evolving our understanding of what it means to be human. The challenges of space exploration compel us to transcend our divisions, to collaborate and innovate in ways that benefit all of humanity. The International Space Station stands as a symbol of what we can achieve when we work together, an orbiting laboratory where scientists from around the world conduct research that advances our knowledge and benefits life on Earth. It is a reminder that, despite our differences, we are all inhabitants of the same planet, united by a common desire to understand and explore. As we look to the future, the possibilities are as boundless as the universe itself. The potential for interstellar travel, the colonization of Mars, the discovery of extraterrestrial life. These are dreams that drive us forward, reminding us that humanity's journey is only beginning. The challenges are immense, but so is our capacity for imagination, resilience, and growth. With each step, we push the limits of what we thought possible, turning science fiction into reality, one breakthrough at a time. Yet, for all the excitement of what lies ahead, we must also remember to look back, to honor our origins, and to care for the planet that gave us life. Earth is not just a stepping stone to the stars. It is a treasure, a rare and beautiful world that remains our only home. As we explore the cosmos, we must carry with us a sense of reverence for our planet and for the delicate balance that sustains life here. In our quest to explore the universe, let us not forget the responsibility we bear to protect and cherish the world that nurtured us. Our journey through the cosmos is a journey of self-discovery, a quest to understand not only the universe, but our own place within it. The stars call to us, not just as destinations to reach, but as reminders of our shared origin and our collective future. We are, in every sense, children of the cosmos, bound to it by the atoms in our bodies and the curiosity in our hearts. As long as we continue to seek, to wonder, and to explore, the story of humanity and the stars will go on, a tale of discovery and connection that spans the ages. So, let us press forward with wonder in our eyes and courage in our hearts, knowing that each new discovery brings us closer to understanding the universe and ourselves. The cosmos awaits, a boundless frontier of beauty, mystery, and possibility. And as we journey onward, we carry with us the spirit of exploration, the drive to seek the unknown, and the profound realization that, in this vast and endless universe, we are part of something truly extraordinary. As we continue to journey deeper into the mysteries of the cosmos, our discoveries challenge us, expand us, and redefine what it means to be part of this immense universe. Each new insight brings with it a reminder that the cosmos is far stranger and more magnificent than we ever imagined. What once seemed like insurmountable boundaries, distances, unknown forces, the constraints of our understanding, are now frontiers, pushing us to ask questions that bridge science and philosophy, humanity and the infinite. In this vast tapestry of existence, we find ourselves compelled to seek not only knowledge but also meaning, purpose, and connection. One of the most profound aspects of our journey is the growing realization that we are interconnected with the universe on every conceivable level. The laws of physics that govern distant galaxies also apply within our bodies. The elements that make up our cells were forged in stars, and the forces that bind our planet are the same forces that orchestrate the dance of planets, stars, and galaxies across the cosmos. This interconnectedness suggests that we are not separate from the universe, but are, instead, deeply woven into its fabric. The concept of cosmic unity is reinforced by the laws of physics, particularly the principles of conservation and symmetry. Conservation laws tell us that certain quantities, like energy, charge, and momentum, remain constant, binding us to a universe where every action resonates with equal and opposite reactions. Symmetry, on the other hand, reflects the balance and harmony inherent in nature, shaping the laws that govern everything from the smallest particles to the largest galaxies. Together, these principles imply an underlying order to the cosmos, a kind of universal coherence that speaks to a profound interconnectedness of all things. This understanding of cosmic unity opens up the question of purpose on a universal scale. Is there an underlying reason why the universe exists in this harmonious, structured way? While science provides us with powerful tools to describe how the universe functions, the question of why remains one of the most compelling and elusive mysteries. Some scientists and philosophers suggest that the universe might have a purpose, a direction, or an inherent drive toward complexity and consciousness. Others argue that purpose is a human construct, something we project onto a fundamentally indifferent cosmos. Regardless, our need to find meaning in the universe reflects a deep-seated desire to connect our individual lives to something larger, something transcendent. In our pursuit of understanding, we encounter some of the most enigmatic aspects of existence, including the very fabric of space-time. Einstein's theory of relativity revolutionized our understanding of space and time by revealing that they are not separate entities, but interconnected dimensions in a four-dimensional space-time continuum. Massive objects like stars and black holes warp space-time, bending the path of light and slowing the passage of time. These distortions in space-time create what we experience as gravity, a force that not only holds our feet to the ground, but also guides planets in their orbits and shapes the structure of the universe. This interplay of space and time is further complicated by the discovery of black holes. Black holes are regions of space where gravity is so intense that not even light can escape. At their center lies a singularity, a point where density becomes infinite and the laws of physics as we know them break down. Here, our concepts of space and time cease to apply in any conventional sense. The singularity remains one of the greatest mysteries in physics, a place where our current theories cannot reach, suggesting that there is a deeper, unknown layer of reality waiting to be uncovered. The enigma of black holes leads to questions about the nature of reality itself. Could black holes be portals to other dimensions? Or could they contain entire universes within them? Some theories propose that every black hole could give rise to a new universe, creating a potentially infinite web of interconnected realities. This concept, known as the multiverse, suggests that our universe might be just one of countless others, each with its own unique laws of physics. If true, the multiverse would redefine our understanding of existence, revealing a reality that is not just vast in space, but also infinitely layered and varied in its forms. Parallel to the mystery of black holes is the question of dark matter and dark energy, the unseen forces that make up about 95% of the universe. Dark matter is thought to provide the scaffolding for galaxies, holding them together through its gravitational influence. Yet, it does not emit, absorb, or reflect light, making it invisible and detectable only through its gravitational effects. Dark energy, on the other hand, is the force driving the accelerated expansion of the universe, pushing galaxies apart at an ever-increasing rate. Together, these phenomena suggest that most of the universe is hidden from our view, an invisible realm that remains one of the most profound mysteries in cosmology. The existence of dark matter and dark energy challenges our understanding of the universe's structure, suggesting that what we see is only a small fraction of the true cosmos. This realization humbles us, reminding us that our knowledge is still limited and that we are just beginning to scratch the surface of a vast, unseen reality. These hidden aspects of the universe invite us to question the nature of perception itself, to consider that our senses and instruments might only reveal a fraction of what truly exists. In this sense, the universe could be far more complex and multidimensional than our current understanding allows. In exploring these hidden dimensions, we also come to reflect on the nature of life and consciousness. The fact that conscious beings exist within the universe, that we can observe, question, and contemplate, suggests that the universe has somehow evolved to produce life capable of self-reflection. This phenomenon, known as the anthropic principle, raises questions about the role of consciousness in the cosmos. Some scientists and philosophers propose that consciousness might not be an accidental byproduct of evolution, but a fundamental aspect of the universe, woven into its very fabric. This idea, though speculative, opens up profound questions about the nature of reality and the potential that consciousness might play an active role in shaping it. The interplay between consciousness and reality is further highlighted by quantum mechanics, which suggests that the act of observation affects the state of particles. This principle, often illustrated by Schrödinger's cat paradox, implies that at a fundamental level, reality is shaped by the presence of an observer. While the exact nature of this relationship remains hotly debated, it raises the possibility that consciousness could be more than a mere accident of biology. It might be an intrinsic part of the universe, a force that participates in the creation of reality. As we grapple with these mysteries, our exploration of the universe becomes a journey of self-discovery. The questions we ask about the cosmos, its origins, its structure, its purpose, mirror our questions about ourselves. Who are we? Why are we here? What is our place in this vast, mysterious universe? These are not just scientific questions. They are deeply existential, reflecting a universal desire to find meaning in our lives and our place in the cosmos. This quest for meaning takes on new significance as we look toward the future of humanity. The prospect of interstellar exploration, the possibility of life beyond Earth, the search for the origins of consciousness, all point to a future where humanity's destiny may be as boundless as the universe itself. Yet, with this potential comes responsibility. As we push forward, we must remember that our actions have consequences, not only for ourselves but for the universe we inhabit. The ethical implications of our journey are profound, urging us to approach our exploration with humility, respect, and a sense of stewardship. Ultimately, the universe offers us both a mirror and a window. A mirror that reflects our deepest questions about existence, and a window that reveals a vast, awe-inspiring reality filled with infinite possibilities. Each new discovery is a step forward in our understanding, yet each answer only leads to more questions, more mysteries, more wonder. In this endless journey, we come to see that the quest to understand the universe is also a quest to understand ourselves. As we gaze into the depths of space, we are reminded that we are part of a story that began billions of years ago, a story of stars and galaxies, of matter and energy, of life and consciousness. This story is still unfolding, and we are both the authors and the readers, contributing to the grand narrative of existence with every question we ask, every discovery we make, and every moment of wonder we experience. The universe calls to us, inviting us to explore, to seek, to dream. And as we continue this journey, we carry with us the legacy of those who came before, the wisdom of our ancestors, and the hope for future generations. In the end, the cosmos is not just a place we inhabit. It is a part of who we are, a vast, infinite expression of existence that reminds us of our shared origin and our shared destiny. So let us move forward with courage and curiosity, with humility and awe, knowing that the universe holds endless mysteries yet to be revealed, endless wonders yet to be discovered. In this journey, we are not alone. We are united by our curiosity, our humanity, and our shared place in the cosmos. The stars beckon, the universe awaits, and our journey continues, a journey of discovery, connection, and boundless wonder. As we venture ever deeper into the cosmic unknown, we find ourselves increasingly connected to the very fabric of the universe. Each step forward reveals not only the outer boundaries of the cosmos, but also the inner depths of our own existence. The further we gaze into the cosmos, the more we sense that this exploration is not just a quest for knowledge, but a profound journey toward understanding the essence of reality itself. One of the most astonishing discoveries in recent years has been the detection of gravitational waves, ripples in the fabric of space-time caused by some of the most violent events in the universe. These waves, predicted by Einstein over a century ago, were first observed by the LIGO Observatory in 2015 when two massive black holes collided and merged. The detection of gravitational waves has opened up a new way of observing the universe, allowing us to listen to cosmic events that were previously invisible to traditional telescopes. These waves carry information about cataclysmic events billions of light years away, enabling us to peer into realms that were once beyond our reach. Gravitational wave astronomy is now a rapidly growing field, and it promises to reveal new insights into the nature of black holes, neutron stars, and even the very early universe. By studying these waves, we can learn more about how black holes form, how they interact, and how galaxies evolve. Moreover, gravitational waves may eventually allow us to probe the universe as it existed moments after the Big Bang, providing a direct glimpse into the conditions of the early cosmos. This ability to listen to the echoes of cosmic history enriches our understanding and gives us a deeper sense of the universe's dynamic, interconnected nature. This discovery has sparked new interest in black holes themselves, which are some of the most fascinating and mysterious objects in the cosmos. Black holes not only warp space-time, but also stretch our understanding of physics to its limits. The singularity at the center of a black hole, a point where density becomes infinite and known physics breaks down, continues to puzzle scientists and suggests that we are still far from fully understanding the fundamental nature of space and time. Some physicists even speculate that black holes may contain holographic information about the universe, holding clues to a deeper layer of reality we have yet to comprehend. In this context, the idea of the holographic universe is especially intriguing. It suggests that our three-dimensional universe might actually be a projection of information encoded on a distant, two-dimensional surface, much like a hologram. This concept, if true, would radically alter our understanding of reality, implying that what we perceive as physical space and time could be emergent properties arising from more fundamental, underlying principles. The holographic principle also ties into the study of black holes, where it is theorized that information entering a black hole is not lost, but encoded on its surface. This raises profound questions about the nature of information, the permanence of matter, and the possibility that our universe is more like a grand illusion than a concrete reality. Parallel to these discoveries, our exploration of exoplanets, the search for Earth-like worlds orbiting distant stars, has become one of the most exciting frontiers in astronomy. In just the past few decades, thousands of exoplanets have been discovered, some of which orbit within the habitable zones of their stars, where conditions might be suitable for liquid water and potentially life. These discoveries ignite our imagination and fuel the hope that we may one day find signs of life beyond Earth. The study of exoplanets has shifted from an unlikely field of exploration to one of the most promising, suggesting that life might exist in diverse forms across the universe, from microbial organisms to advanced civilizations. The search for life beyond Earth is not limited to distant star systems. Within our own solar system, moons like Europa, Enceladus, and Titan have become prime targets for exploration due to the presence of subsurface oceans, organic molecules, and other ingredients for life. These icy worlds, once thought barren, now seem capable of hosting microbial life in hidden, liquid environments beneath their frozen crusts. Missions like the Europa Clipper, set to launch in the coming years, aim to investigate these moons more closely, potentially answering the question of whether life exists elsewhere within our own cosmic neighborhood. The prospect of discovering extraterrestrial life, even in its simplest forms, would be transformative. It would challenge our assumptions about biology and force us to rethink life as a purely Earth-based phenomenon. Finding life elsewhere would imply that life could be a natural outcome of planetary processes, emerging wherever conditions are favorable. Such a discovery would not only expand our understanding of biology, but also our sense of identity, showing that we are part of a much larger, possibly interconnected community of life. This quest for life and understanding has led to the concept of panspermia, the theory that life's building blocks may be spread throughout the cosmos, carried on meteorites, comets, and other celestial bodies. According to this theory, life could have originated on other planets or in interstellar space, and then seeded worlds across the universe, including Earth. If panspermia holds true, it would mean that life is a cosmic phenomenon dispersed among the stars, and that we are not isolated beings but participants in a universe where life is as natural and widespread as the stars themselves. While these scientific advances are remarkable, they also bring us face to face with philosophical and ethical questions. If we discover life on another planet or moon, how should we approach it? Do we have the right to explore and potentially disrupt ecosystems that have evolved in isolation for millions or billions of years? These questions compel us to consider the concept of cosmic stewardship, the responsibility to approach space exploration with respect and caution, recognizing that we are custodians of the universe as much as explorers. The notion of stewardship extends beyond Earth, reminding us that every planet, moon, and star is a unique part of the cosmos, worthy of preservation and care. Our journey into space is thus not only a scientific endeavor, but a moral one, urging us to recognize the interconnectedness of all things and our responsibility to protect and cherish the universe we explore. As we push the boundaries of what is possible, we must also ensure that our actions honor the dignity of the cosmos, respecting the natural beauty and diversity that exist beyond our planet. This sense of cosmic ethics becomes even more essential as we consider the possibility of human expansion into space, the establishment of colonies on Mars, and the exploration of distant worlds. Looking to the future, the vision of becoming a multi-planetary species is no longer the realm of science fiction. Advances in technology, particularly in propulsion, habitat development, and sustainable energy, bring us closer to the day when humanity may establish a permanent presence on other planets. Mars is the first likely candidate, with plans for human missions in the next decade. But the vision extends beyond Mars to other moons, asteroids, and, one day, perhaps even star systems beyond our own. This expansion holds the promise of safeguarding humanity against planetary catastrophes, but it also calls us to think about the kind of civilization we want to build among the stars. The idea of interstellar exploration brings us to the next frontier, the search for habitable planets beyond our solar system and the possibility of faster-than-light travel. Concepts such as warp drives, wormholes, and other advanced theoretical propulsion methods are being explored, however distant they may seem from our current capabilities. These technologies, if realized, could unlock the stars, allowing us to explore and perhaps settle in far-flung corners of the galaxy. While these ideas are still speculative, they remind us of the power of human imagination and the potential for technological progress to reshape our future. In contemplating the cosmos, we are also drawn to questions about our own existence. The mystery of consciousness, our ability to think, feel, and perceive, remains one of the most profound enigmas of all. Some theories suggest that consciousness might be a fundamental aspect of the universe, an intrinsic quality that pervades all matter. This idea, while speculative, invites us to consider that awareness may not be limited to biological life, but could be a universal property, woven into the fabric of space-time itself. If true, this would imply that the universe is not only a place of matter and energy, but also of mind and perception, a self-aware cosmos experiencing itself through countless forms and beings. In the end, our exploration of the universe is as much a journey of self-discovery as it is of scientific investigation. Each discovery, whether it be a distant planet, a gravitational wave, or the faint possibility of life beyond Earth, brings us closer to understanding our own origins, our own purpose, and our own connection to the cosmos. We are not separate from the universe. We are an expression of it, conscious beings woven into the vast and intricate web of existence. As we continue on this journey, we are reminded that the universe is an endless well of mysteries, each one an invitation to wonder and to dream. The stars, galaxies, and planets we observe are not just objects of study. They are gateways to understanding the profound unity of all things, the shared origin of life, and the boundless potential of human exploration. In this grand tapestry, we find not only answers but questions that drive us forward, that inspire us to look further, to think deeper, and to never stop seeking. The cosmos awaits us, a vast, infinite realm of discovery and meaning. And as we journey into the unknown, we carry with us the spirit of curiosity, the courage to explore, and the wisdom to respect the universe and our place within it. The universe calls us forward, and with each step, we bring the story of humanity and the stars closer together, forever intertwined in the boundless quest for knowledge, wonder, and understanding. As our cosmic journey stretches on, the mysteries deepen, beckoning us into realms that challenge both our scientific understanding and our philosophical musings. The vastness of the universe is not just a frontier of exploration. It is a mirror, reflecting questions that resonate with the very core of human existence. Each star, each planet, each galaxy is a reminder of the enormity of the unknown, inviting us to explore not only outward but inward, as we seek to unravel the profound relationship between ourselves and the cosmos. The discovery of new forms of celestial phenomena, like magnetars, pulsars, and quasars, continues to expand our understanding of the cosmic landscape. These exotic objects are the results of extreme processes and environments that push the boundaries of what we thought possible. For instance, magnetars are neutron stars with magnetic fields trillions of times stronger than Earth's, so powerful that they can warp atoms and emit bursts of energy that, if observed from Earth, would outshine the entire galaxy. Pulsars, rotating neutron stars, emit beams of radiation so regular that they have been compared to cosmic lighthouses, their signals reaching us with a precision that challenges the limits of our timing technology. Quasars, meanwhile, are powered by supermassive black holes at the centers of galaxies, shining with an intensity that allows us to observe them from billions of light years away. Each of these objects tells a story of the universe's raw power, its cycles of birth and destruction, and the conditions that exist far beyond the range of human experience. These discoveries not only reveal the mechanisms that govern extreme environments, but also bring us closer to understanding the ultimate fate of stars, galaxies, and even the universe itself. As stars reach the end of their lives, they become factories of the elements, creating everything from carbon and oxygen to gold and uranium. When they explode as supernovae, they scatter these elements into the cosmos, seeding future generations of stars and planets. This stellar recycling process shows us that creation is built on transformation, and that every part of the universe is connected in a grand, ongoing cycle of matter and energy. Understanding these cosmic processes has led to the realization that our own solar system is part of this continuous cycle. Our sun is a second-generation star, born from the remnants of earlier stellar explosions, and Earth itself is formed from recycled stardust. The very atoms in our bodies, carbon, oxygen, nitrogen, originated in the hearts of long-dead stars. In a literal sense, we are stardust given consciousness, the universe becoming aware of itself through us. This connection binds us to the stars in a way that transcends the physical, giving us a sense of belonging to something far greater and more ancient than humanity alone. As we delve into the intricacies of the universe, the nature of time itself becomes a profound mystery. Time, as we experience it, moves in a linear direction, from past to present to future. Yet, theories of physics suggest that time may not be as rigid or absolute as it appears. In the realm of general relativity, massive objects can warp time, causing it to slow down in intense gravitational fields. This phenomenon, known as gravitational time dilation, means that time flows differently depending on the strength of gravity in a given region. Near a black hole, for instance, time could almost come to a halt relative to an observer further away, creating environments where time operates in ways that defy our everyday experience. The possibility that time is flexible and subject to the conditions of space raises profound questions about the nature of reality. Could time be an illusion, a construct that exists only in our perception? Some theories in quantum mechanics and cosmology suggest that time may not be fundamental to the universe, but rather an emergent property arising from deeper, timeless principles. This idea challenges our understanding of existence itself, suggesting that what we perceive as now might be just one layer of a multidimensional reality. These ideas lead us to one of the most profound and unresolved questions in modern science: the nature of the universe's beginning. The Big Bang Theory describes the origin of our universe as a rapid expansion from an extremely hot, dense state. But what caused this event? And what, if anything, came before it? Some cosmologists speculate that the Big Bang may not have been the beginning, but rather a transition from a previous state, perhaps a cycle in an eternal loop of universes. Others propose that our universe might be one bubble in a multiverse, an infinite sea of universes, each with its own unique laws and conditions. The multiverse theory, while speculative, opens up staggering possibilities. If our universe is just one of many, it implies that reality itself is far grander than we can imagine. Each universe within the multiverse might have different physical constants, different structures, even different forms of life or consciousness. In this vast expanse of possibilities, our universe might be just one small chapter in an endless story of creation and evolution, a single note in the cosmic symphony. This idea of multiple universes forces us to rethink our place in the cosmos. Are we an isolated phenomenon, or is there a greater, interconnected structure that binds all existence together? If other universes do exist, are they accessible to us? Could there be versions of ourselves in these other realms, living out different lives, making different choices? Such questions stretch the boundaries of science and philosophy, inviting us to explore the very limits of knowledge and existence. At the same time, the search for extraterrestrial life has led to the consideration of entirely different forms of life, challenging our understanding of biology. Scientists now entertain the possibility of shadow biospheres, ecosystems of life that may exist alongside us, but in forms so different from our own that we have yet to recognize them. Life based on silicon instead of carbon, for instance, or microbial life that thrives in environments we consider hostile. These ideas suggest that life is not confined to a single model, but is adaptable, resilient, and capable of thriving in conditions unimaginable to us. In the context of the cosmos, this adaptability means that life could exist in forms and places beyond our wildest imaginings. Microbial life might flourish under the icy crust of moons like Europa, living off chemical energy in subsurface oceans. Intelligent life, if it exists, could communicate using methods we cannot yet comprehend or perceive, operating on wavelengths or frequencies that evade our instruments. The search for life, therefore, is as much a challenge to our imagination as it is a scientific endeavor, requiring us to expand our definition of what it means to be alive. The implications of finding life beyond Earth would be transformative. It would expand our understanding of biology, challenge our sense of uniqueness, and potentially open up new ways of connecting with the universe. If intelligent life exists, the discovery would reshape our understanding of civilization, technology, and consciousness. It would remind us that humanity is part of a much larger community of life, bound by shared origins in the stardust of the cosmos. As we contemplate these possibilities, the ethical dimensions of space exploration come into sharper focus. Our growing capability to explore and, one day, to colonize other worlds brings with it a responsibility to protect and respect these environments. Whether it's a barren moon, an asteroid, or a potentially habitable planet, each celestial body has its own history, its own story within the cosmic tapestry. As we reach out into the stars, we are called to practice cosmic stewardship, to treat the universe with the same reverence we strive to show toward our own planet. This responsibility is not just about preservation, it is also about humility. The more we learn, the more we realize how little we truly know. Each discovery reveals new layers of mystery, reminding us that the universe is a place of infinite complexity and beauty. Our journey into the cosmos is an invitation to remain humble, to recognize that we are but one small part of a vast, interconnected whole. This humility allows us to approach the unknown with openness and wonder, to acknowledge the limits of our understanding even as we strive to expand them. Our journey through the cosmos is as much about introspection as it is about exploration. Each discovery brings us closer to the realization that we are connected to everything around us, from the atoms in our bodies to the distant galaxies that light up the night sky. This sense of interconnectedness is both humbling and inspiring, reminding us that we are participants in a story that began long before us and will continue long after we are gone. As we gaze into the depths of space, we are reminded that the universe is not just a collection of stars and planets, but a living, dynamic whole, a place where creation and destruction, order and chaos, light and darkness coexist in a delicate balance. This cosmic balance is not merely an abstract concept. It is the foundation of our existence, the framework that allows life, consciousness, and wonder to arise. The stars call to us, not as distant destinations to conquer, but as beacons of mystery and beauty, inviting us to participate in the story of existence. Our journey is far from over. Each question leads to another. Each discovery reveals a new horizon, and each step brings us closer to understanding not only the universe but ourselves. The cosmos is infinite, its mysteries boundless, and our curiosity insatiable. As we continue on this path, let us carry with us a spirit of awe, a commitment to stewardship, and a willingness to embrace the unknown. The universe awaits, and in its vastness, we find not only answers, but also an endless source of wonder. This is our journey, our exploration, our story, and the universe is our home. As our exploration of the cosmos deepens, we find ourselves entering realms of discovery that feel both familiar and profoundly alien, reminding us that the universe is a place of contrasts and paradoxes. Each new insight into the nature of existence expands our sense of wonder, pushing us to confront questions that blur the lines between science, philosophy, and even spirituality. The cosmos, it seems, is as much a mystery to our minds as it is a spectacle to our senses, an endless frontier that invites us not only to observe but to contemplate, to imagine, and to connect. One of the most awe-inspiring concepts in modern cosmology is the notion of cosmic inflation, a period of rapid expansion that occurred in the first fractions of a second after the Big Bang. This inflationary phase stretched the universe exponentially, transforming it from a minuscule point into an expansive cosmos in an instant. This phenomenon, which defies everyday experience, laid the groundwork for the structure of the universe as we see it today. The cosmic microwave background radiation, a faint glow that permeates all of space, is a direct remnant of these early moments. It is like a photograph of the universe's infancy, capturing the faint echoes of a time when space, time, and matter were just beginning to take shape. The study of cosmic inflation brings us to questions that reach the edge of scientific knowledge. If inflation happened, what caused it? Was it a one-time event? Or is it a recurring process that creates multiple universes? Some theories propose that inflation could occur endlessly, producing bubble universes in a vast, ever-expanding multiverse. In this view, our universe is just one bubble among countless others, each with its own laws, dimensions, and possibly its own forms of life. This eternal inflation scenario expands our understanding of reality, suggesting that the cosmos may be a tapestry woven from countless threads of existence, each one unique yet connected to the whole. The concept of a multiverse challenges our notions of uniqueness and isolation. If there are indeed infinite universes, then our own may be one among countless variations, each with different outcomes and possibilities. Some scientists speculate that, in this vast landscape, there could be other versions of ourselves living different lives, making different choices. The multiverse theory suggests that reality itself may be far more complex than we can perceive, a boundless realm of infinite possibilities that extend beyond our comprehension. This vastness reminds us that the limits of our perception shape the way we understand the universe. The observable universe, the portion we can see, is limited by the speed of light and the age of the cosmos. Beyond this observable boundary, the universe likely continues, stretching into depths we cannot yet reach. This horizon serves as both a boundary and a promise, a reminder that for every mystery we solve, there are countless others waiting just beyond our grasp. It is a humbling realization, emphasizing that our understanding is always partial, our knowledge always incomplete. Yet, as we reach for answers, we are also reminded of the mysteries within ourselves. Consciousness, the quality that enables us to perceive, reason, and reflect, remains one of the greatest enigmas of all. How does subjective experience arise from the physical brain? What is the nature of awareness? And why does it exist at all? Some scientists and philosophers suggest that consciousness might be fundamental, a property of the universe itself, rather than a byproduct of biology. This idea, known as panpsychism, proposes that consciousness exists at varying levels across all matter, from atoms to galaxies, implying that the universe is not a cold, lifeless void, but a realm filled with awareness in ways we are only beginning to understand. The idea that consciousness could be a universal property offers a new perspective on our connection to the cosmos. If awareness is woven into the fabric of existence, then we are not isolated minds observing a distant universe, but active participants in a vast, interconnected network of perception. This view aligns with ancient philosophical traditions that see the universe as a living whole, where everything is connected and every action resonates across the entirety of existence. In this perspective, consciousness is not confined to individual minds, but is part of the universe's expression of itself, a cosmic awareness experiencing reality through myriad forms. This idea brings us to the edge of science and philosophy, inviting us to consider the possibility that the universe has a purpose, a direction, or even an intrinsic meaning. While science traditionally avoids questions of purpose, focusing instead on how things happen, the structure of the universe and the emergence of consciousness lead us to wonder, is there an underlying order or intelligence guiding the cosmos? Are we, as conscious beings, a part of the universe's drive toward complexity and self-awareness? Or is meaning something we create, a reflection of our own need to find significance in a vast and different universe? These questions bring us to the study of astrobiology and the search for life beyond Earth. The discovery of even the simplest microbial life elsewhere would profoundly impact our understanding of biology, consciousness, and the potential interconnectedness of life throughout the cosmos. Scientists have found organic molecules on comets, asteroids, and even distant exoplanets, suggesting that the building blocks of life are common in the universe. Moons like Europa and Enceladus, with their subsurface oceans, could harbor environments where life might exist, while Mars, with its history of water, remains a prime candidate for the discovery of ancient microbial life. The search for extraterrestrial intelligence, SETI, takes this quest one step further, aiming to detect signals from intelligent civilizations that may exist elsewhere in the galaxy. While the search has so far yielded no definitive results, the sheer number of stars and planets suggests that life, and perhaps intelligent life, may not be unique to Earth. If we were to discover intelligent life beyond our planet, it would fundamentally alter our understanding of ourselves, reshaping our sense of purpose and place in the cosmos. Such a discovery would show that consciousness, curiosity, and perhaps even culture are not limited to humanity, but are universal expressions of life. As we look for life beyond Earth, we are also learning to see our own planet from a new perspective. The overview effect, experienced by astronauts viewing Earth from space, reveals our world as a single, fragile ecosystem, a delicate blue marble suspended in the vastness of space. This perspective emphasizes the interconnectedness of all life on Earth, reminding us that our survival is intertwined with the health of our planet. In the context of the cosmos, Earth is not only our home, but a rare and precious haven, a cradle of life that we have a responsibility to protect. Our exploration of space has thus deepened our awareness of the need for stewardship, both of our own planet and of the universe beyond. As we consider the possibility of colonizing other planets or mining resources from asteroids, we are called to approach these pursuits with a sense of ethics and respect. The concept of cosmic stewardship suggests that we are caretakers of the universe, responsible for preserving its beauty, diversity, and complexity. Just as we are learning to care for Earth's ecosystems, we must also consider how to interact with other worlds, respecting their unique environments and potential forms of life. In looking outward, we are also invited to look inward, to recognize that our desire to explore the cosmos is a reflection of our own inner journey. The questions we ask about the universe are ultimately questions about ourselves, about our origins, our destiny, and our place within the grand design. As we contemplate the mysteries of space and time, we are also seeking answers to the fundamental questions of existence. Who are we? Why are we here? What is the nature of reality? And what is our role within it? The more we learn, the more we realize that the journey is as important as the destination. The search for answers, the pursuit of knowledge, and the experience of wonder are, in themselves, expressions of our connection to the cosmos. In the end, it may be that the purpose of our exploration is not to find a final answer, but to participate in the unfolding of the universe, to be part of its grand narrative, to observe, to question, and to marvel at the boundless beauty and complexity of existence. As we stand at the threshold of a new era in space exploration, we carry with us the hopes and dreams of generations. The stars call to us, not merely as points of light, but as symbols of possibility, as reminders that we are part of something infinitely larger than ourselves. Each new discovery, each question answered, and each mystery unveiled draws us deeper into the cosmic story, a story that began long before us and will continue long after. So let us move forward with courage, humility, and a sense of wonder. Let us remember that we are not isolated beings on a solitary planet, but participants in a vast, interconnected cosmos. The universe is both our origin and our destination, and as we journey through it, we are bound to it in ways we are only beginning to understand. The cosmos is our home, our inspiration, and our endless frontier, and in exploring it, we discover not only the nature of reality, but also the nature of ourselves. In the infinite vastness of the universe, we are a single, conscious breath, and as we continue our journey, we carry with us the spark of curiosity that lights up the darkest spaces, the hope that drives us to explore, and the love for a universe that, in all its grandeur, has given us the gift of awareness. As we continue our journey through the cosmos, our understanding of existence itself deepens, reaching realms where science and philosophy converge, and where wonder transforms into a profound sense of reverence. With each revelation, we are reminded that the universe is not just a place we observe from afar. It is a dynamic, interconnected web of energy, matter, and mysteries. Every new insight reveals not only the structure of the cosmos, but also its intricate, almost poetic complexity. In many ways, exploring the universe is akin to reading an epic story written in the language of stars, galaxies, and fundamental forces, a story in which we, too, play a part. One of the most profound themes emerging in cosmology is the idea of cosmic evolution. Just as species evolve over time through natural selection, so too does the universe evolve, shaping itself through processes that bring structure, diversity, and complexity. From the birth of the first particles after the Big Bang to the formation of stars, galaxies, and planets, the universe has been a theater of continuous change and transformation. In the beginning, there was a simplicity in the cosmos, a seething sea of particles, a void waiting to take shape. Over billions of years, gravity, energy, and matter have woven this chaos into galaxies, star clusters, and nebulae, crafting a cosmic tapestry of unimaginable scale and beauty. This idea of cosmic evolution reminds us that the universe is, in essence, a creative force. It takes raw potential and shapes it into something greater, something alive with possibility. The conditions that allowed for life on Earth were not the product of a single event, but the result of countless interactions, from the fusion processes in ancient stars to the violent explosions that scattered elements across space, seeding future generations of stars and planets. We are the product of this long, evolutionary journey, part of an unbroken chain that links us to the earliest moments of creation. The interconnectedness of life and the cosmos brings us to one of the most profound insights of all: the concept of cosmic heritage. The atoms in our bodies were born in stars that lived and died billions of years ago. When we look up at the night sky, we are not only seeing distant stars, we are seeing our origins, the birthplace of the matter that forms us. This connection transcends space and time, reminding us that we are not separate from the universe, but an expression of it. Our consciousness, our ability to wonder and to seek understanding, is itself an extension of the cosmos, a way in which the universe experiences itself. As we explore this concept, we encounter a fundamental question about the nature of life and consciousness. Are we a rare phenomenon, a unique product of Earth-specific conditions? Or is life a cosmic imperative, emerging wherever the conditions are favorable? This question has driven scientists to search for signs of life beyond Earth, a quest that has taken on new urgency with the discovery of thousands of exoplanets orbiting distant stars. Some of these planets exist within the habitable zone, the region around a star where temperatures could allow for liquid water, a key ingredient for life as we know it. The search for life in the universe challenges us to expand our understanding of biology and to imagine forms of life that may be entirely unlike anything we know. Could there be organisms that thrive in environments of extreme heat, cold, or acidity? Could life exist in forms based on silicon rather than carbon, or in solvents other than water? The diversity of life on Earth, from deep-sea extremophiles to microbes thriving in volcanic vents, suggests that life is remarkably adaptable. If life exists beyond Earth, it may not look like us or share our biology, yet it would still be part of the same cosmic story, a fellow traveler in the journey of existence. The implications of finding life elsewhere are profound. If we discover even a simple organism on another world, it would mean that life is not a fluke of Earth's environment, but a natural outcome of cosmic processes. Such a discovery would suggest that the universe is inherently capable of producing life, that it is in some sense alive. This realization would fundamentally alter our perspective, shifting our view of life from a rare anomaly to an intrinsic quality of the cosmos itself. The quest to understand life beyond Earth is also a quest to understand the nature of intelligence and consciousness. If intelligent civilizations exist elsewhere, they may have evolved in environments vastly different from our own, with senses, technologies, and ways of thinking that are beyond our comprehension. Could they communicate with us? Or would their perception of reality be so alien that our minds would struggle to bridge the gap? This prospect challenges us to think beyond human limitations and to recognize that consciousness might take forms we cannot yet imagine. Our search for extraterrestrial intelligence is, at its core, a search for connection, a hope that, somewhere in the vastness of the cosmos, we might find others who have asked the same questions, who have looked at the stars with the same wonder. It is a reminder that our desire to understand the universe is also a desire to understand ourselves and our place within it. The discovery of another civilization, or even the faintest hint of one, would be one of the most transformative events in human history. It would challenge our assumptions, expand our worldview, and perhaps offer a sense of companionship in the vast, silent spaces between the stars. As we contemplate these possibilities, we are also reminded of our responsibility to each other and to our planet. Earth, our only known cradle of life, is a rare and precious oasis in a universe that can be harsh and unforgiving. Our exploration of the cosmos has given us a new perspective on our world, showing us that we are all part of a single ecosystem, bound together by our shared origins and our shared destiny. This understanding calls us to protect and cherish our planet, to recognize that our actions have consequences not only for ourselves but for the future of life on Earth. Our journey into space has also brought us face to face with the ethical implications of exploration and expansion. If we are to become an interplanetary species, venturing to Mars, the moons of Jupiter and Saturn, or beyond, we must consider how our presence might impact these worlds. Do we have the right to alter other planets, to reshape them to suit our needs? Or do we have a duty to preserve their natural state, respecting them as part of the cosmos's intrinsic beauty and complexity? These questions challenge us to rethink our role as explorers, urging us to balance our desire for discovery with a respect for the environments we encounter. In this sense, the universe becomes not only a frontier of exploration, but a place of ethical reflection. As we expand our reach, we are called to approach the cosmos with humility and a sense of stewardship, to recognize that we are part of something much larger than ourselves. This perspective invites us to view space exploration not as a conquest, but as a collaboration, a partnership with the universe that respects its vast diversity and honors the potential for life in all its forms. As we look to the future, we find ourselves on the cusp of a new era, one in which humanity's destiny may extend beyond Earth, perhaps even beyond the solar system. Advances in technology, from artificial intelligence to advanced propulsion systems, are bringing us closer to achieving interstellar travel, to exploring the far reaches of the galaxy, and to building sustainable colonies on other planets. These possibilities inspire us, filling us with a sense of purpose and wonder. Yet they also remind us of the responsibilities we bear as stewards of our home and as caretakers of the universe. In this journey, we carry with us the legacy of those who came before, the wisdom of ancient astronomers, philosophers, and explorers who looked up at the stars with the same curiosity and awe. We are the continuation of that legacy, driven by the same desire to know, to understand, and to connect. Each generation adds its own chapter to the story of humanity and the cosmos, building on the discoveries of the past and passing on the torch of exploration to those who will come after us. Ultimately, the universe offers us not only a place to explore, but a deeper understanding of who we are. We are not isolated beings, separate from the cosmos. We are expressions of it, woven into its fabric, part of its endless cycle of creation and transformation. The atoms that make us up were born in stars, and one day, they will return to the cosmos, to become part of new stars, new worlds, new life. In this way, our story is the universe's story, a brief chapter in a narrative that stretches across eternity. As we move forward, let us carry with us a sense of wonder, a commitment to stewardship, and a willingness to embrace the unknown. The cosmos calls to us, inviting us to discover, to question, and to dream. And in answering that call, we fulfill a purpose as ancient as the stars themselves, to explore, to seek understanding, and to celebrate the boundless beauty of existence. So, let us continue our journey, knowing that each step brings us closer to the heart of the universe and in a profound sense, closer to ourselves. The stars await, the mysteries abound, and the story of humanity and the cosmos is far from over. In this infinite, interconnected universe, we are both the seekers and the sought, bound to the stars, the galaxies, and each other in a timeless dance of wonder and discovery. As we press on in our cosmic voyage, each revelation brings us to the edge of understanding, a threshold where known science meets profound mystery. The universe, it seems, is woven from threads of complexity that challenge our deepest assumptions about reality, existence, and the limits of human potential. This journey is not only a physical one across vast distances, but also an intellectual and spiritual journey into the essence of what it means to be conscious, curious beings in a universe that may be infinitely more complex and beautiful than we ever imagined. One of the most exciting frontiers in modern science is the study of dark matter and dark energy, two mysterious components that make up 95% of the universe, yet remain almost entirely undetectable. Dark matter exerts a gravitational influence on galaxies, holding them together and shaping the cosmic structure. Without it, galaxies would fly apart, unable to maintain their form. Yet, despite its crucial role, dark matter does not emit or reflect light, leaving it invisible and detectable only by its gravitational effects. Dark energy, on the other hand, is an even stranger phenomenon, driving the accelerated expansion of the universe, pushing galaxies away from each other at ever-increasing speeds. Together, dark matter and dark energy point to a hidden realm of the cosmos that eludes our senses and defies our current understanding. The quest to understand these unseen forces has led to the development of sophisticated experiments and observatories, from underground detectors to high-powered telescopes, all designed to capture even the faintest signs of dark matter. Some scientists believe that dark matter could consist of exotic particles that interact only weakly with regular matter, while others speculate that it could represent a fundamental property of space itself, a shadow of higher dimensions beyond our perception. These ideas are not only scientifically compelling, but philosophically profound, suggesting that the universe we experience is only a partial view of a much larger, multidimensional reality. The possibility of higher dimensions brings us to one of the most mind-bending theories in modern physics, string theory. According to this theory, the fundamental particles we observe, electrons, quarks, photons, are not point-like objects but tiny, vibrating strings of energy. The different ways these strings vibrate give rise to the various particles and forces in the universe. String theory also proposes the existence of additional spatial dimensions beyond the three we experience, dimensions that may be hidden from us, curled up at scales too small to detect. If true, string theory would unify gravity with the other fundamental forces, potentially providing a theory of everything that explains all of existence in a single framework. String theory, while still unproven, offers a tantalizing glimpse into a universe that is far more interconnected and elegant than we may realize. It suggests that all of reality is fundamentally connected, that every particle, every force, every interaction is a manifestation of a single, underlying structure. This idea resonates with ancient philosophies and spiritual traditions that describe the universe as a unified whole, where separations are illusions and everything is interconnected. In this view, the boundaries between matter, energy, and consciousness may be less rigid than we assume, hinting at a reality where everything is woven from the same cosmic fabric. The concept of unity also resonates in the study of quantum entanglement, a phenomenon where particles become linked in such a way that the state of one instantly affects the state of another, regardless of the distance between them. This spooky action at a distance, as Einstein famously described it, suggests that particles can remain connected across vast distances, hinting at an underlying layer of reality where space and time are not the ultimate limits. Quantum entanglement has practical applications in fields like quantum computing and cryptography, yet it also raises profound questions about the nature of reality. Could it be that the universe operates on a level of connectivity that we are only beginning to glimpse, where information, energy, and perhaps even consciousness can traverse space and time in ways we cannot yet comprehend? The implications of quantum entanglement challenge our classical understanding of the universe, opening the door to concepts like the holographic principle. This theory suggests that all the information contained in a volume of space can be represented on its boundary, much like a hologram. If true, this would imply that our universe might be a projection, a three-dimensional image of information encoded on a two-dimensional surface. This concept transforms our understanding of reality, suggesting that what we experience as physical space could be an emergent phenomenon, a kind of cosmic illusion. These ideas bring us closer to contemplating the nature of consciousness itself. How is it that we, beings made of atoms and particles, are able to perceive, think, and reflect? Some theories propose that consciousness might be a fundamental property of the universe, embedded within the very fabric of reality. This idea, known as panpsychism, suggests that consciousness exists in varying degrees throughout all matter, that every particle has some form of awareness, however basic. While this concept remains speculative, it challenges the traditional view that consciousness is exclusive to biological life, opening the possibility that the universe itself may have a kind of intrinsic awareness. The idea that consciousness is universal adds a new dimension to the way we understand life and our place in the cosmos. If consciousness is not confined to human beings or even to biological organisms, it could mean that the universe is not a cold, indifferent machine but a living, dynamic system, experiencing itself through countless forms and manifestations. This perspective aligns with ancient philosophical and spiritual traditions that describe the universe as an interconnected whole, where every particle, every star, every life form is a unique expression of a single, unified consciousness. In this view, our thoughts, actions, and perceptions are not isolated events, but parts of a cosmic dance, a collective unfolding of awareness. This understanding has profound implications for our relationship with the cosmos. If we are part of a conscious universe, then our quest to understand the stars is also a quest to understand ourselves. The questions we ask about the nature of reality, time, and existence are reflections of the universe's own curiosity, its drive to know and experience itself. This perspective invites us to view science not merely as a tool for control and prediction, but as a way to participate in the universe's unfolding, to engage in a dialogue with the cosmos that deepens our understanding of both the outer and inner worlds. The journey to understand the universe is therefore not only a physical journey, but an exploration of meaning, purpose, and interconnectedness. Our search for extraterrestrial life, for example, is as much about companionship as it is about biology. The possibility that we may not be alone in the universe stirs a longing for connection, a desire to find others who, like us, have looked up at the stars and wondered about the nature of existence. If we were to encounter intelligent life beyond Earth, it would not only expand our understanding of consciousness and civilization, but also remind us that we are part of a larger community of beings, bound together by our shared origins in the stardust of the cosmos. This sense of interconnectedness extends to our responsibility as stewards of our planet and potentially other worlds. As we consider the possibility of colonizing Mars or mining asteroids, we are called to reflect on the ethical dimensions of exploration. Do we have the right to alter other planets, or should we preserve their natural state? What responsibility do we bear toward any life, however simple, that we might encounter on other worlds? These questions urge us to approach space exploration with humility and respect, recognizing that every world, every ecosystem, is part of a cosmic heritage that deserves care and consideration. As we look toward the future, the vision of humanity as a multi-planetary species inspires both hope and caution. The idea of establishing colonies on Mars, exploring the icy moons of Jupiter and Saturn, and perhaps even reaching other star systems fills us with a sense of wonder and purpose. Yet, this vision also reminds us that our actions have consequences, that we carry with us a responsibility to preserve the beauty and integrity of the cosmos. In our pursuit of new worlds, we must remember that we are part of an interdependent web of life, bound not only to each other, but to the entire universe. In the end, our exploration of the cosmos is an invitation to embrace the mystery of existence. The universe is not merely a series of objects and forces, but a living, breathing reality, a vast, intricate dance of matter, energy, and consciousness. Each new discovery, each question we ask, brings us closer to understanding our own nature, to recognizing that we are not separate from the cosmos, but integral to its story. The atoms in our bodies, the thoughts in our minds, the emotions we feel, all are expressions of the same cosmic essence that gives rise to galaxies, stars, and planets. As we continue this journey, let us carry with us a sense of wonder, humility, and reverence for the universe and our place within it. The cosmos is not just a destination. It is our origin, our future, and our home. It is the stage upon which the drama of existence unfolds, a place of infinite beauty and boundless potential. In exploring the stars, we are not merely searching for knowledge. We are participating in the greatest story ever told, a story that began with the first spark of creation and will continue long after we are gone. So let us move forward, with curiosity in our minds and gratitude in our hearts, knowing that each step brings us closer to understanding the universe and ourselves. The journey is endless, the mysteries are infinite, and the universe awaits us, calling us to explore, to connect, and to marvel at the vast, interconnected web of existence. In this boundless cosmos, we are both the explorers and the explored, forever united in a cosmic quest for meaning, understanding, and wonder. As our journey through the cosmos stretches onward, we find ourselves not only voyaging through the vastness of space, but also diving deep into the philosophical and existential dimensions of our own nature. Each revelation, each observation, each theory leads us to more profound questions, reminding us that understanding the universe may be an endless pursuit, a cosmic dialogue that continually unfolds with no final answers. This journey, though rooted in science and discovery, is equally a journey of self-reflection, where each new insight into the universe is also an insight into ourselves. One of the most humbling realizations we've encountered is the sheer scale of the cosmos. The observable universe spans billions of light years, containing an estimated 2 trillion galaxies, each filled with billions or even trillions of stars. Beyond this lies the vast unknown, a space that may be infinite, populated with phenomena we have yet to imagine. This immense scale forces us to confront our own smallness, yet it also inspires a deep sense of awe, reminding us that we are part of something unimaginably grand. Our world, our lives, are small threads in an enormous cosmic tapestry, a tapestry so vast that we may never fully understand its shape or purpose. This cosmic scale also brings us to questions about time and eternity. When we look at distant galaxies, we are looking back in time, seeing them as they were millions or even billions of years ago. The light from these galaxies has traveled unimaginable distances to reach us, and in viewing it, we are glimpsing the ancient past of the universe. Time itself becomes a dimension we can observe, almost touch, reminding us that the cosmos is not static but dynamic, forever evolving. The stars we see in the night sky are beacons from the past, whispering stories of cosmic epochs long gone. In contemplating time, we are drawn to the concept of cosmic history, an understanding that the universe itself has a beginning, a middle, and perhaps an end. The story of the cosmos began with the Big Bang, an explosion of unimaginable energy that set space and time into motion. But what existed before the Big Bang? And what, if anything, will come after? Some theories suggest that the universe could be cyclical, an eternal rhythm of expansions and contractions, with each Big Bang marking the birth of a new universe. Others propose that the cosmos will continue expanding until it reaches a state of entropy, where all matter and energy are evenly distributed, leading to a heat death, a silent, cold end where all is still. The possibility of a cyclic universe suggests that the cosmos might have no true beginning or end, that creation and destruction are part of an endless cycle. In this view, every end is a new beginning, every death a prelude to rebirth. This perspective resonates with ancient spiritual philosophies, which have long spoken of cycles of life, death, and renewal. It hints at a universe that is self-sustaining, a cosmic phoenix rising from its own ashes, forever renewing itself in a dance of energy and matter. The concept of eternity also brings us to the nature of existence itself. Why does the universe exist at all? Why is there something rather than nothing? This question lies at the heart of both science and philosophy, and it remains one of the greatest mysteries of all. Some physicists suggest that the universe may be a quantum fluctuation, a spontaneous emergence from a state of nothingness. Others propose that the universe exists because it must, that the laws of physics are such that existence is inevitable. Yet these answers, while intriguing, only scratch the surface, leaving us to wonder about the deeper purpose or meaning, if any, behind existence. In this context, we encounter the idea of the anthropic principle, the notion that the universe appears to be fine-tuned for the emergence of life and consciousness. The constants of nature, from the strength of gravity to the charge of the electron, are precisely calibrated to allow for the formation of stars, planets, and, ultimately, beings like us who can ponder the cosmos. Some scientists argue that this fine-tuning is evidence of a multiverse, where countless universes exist, each with different physical laws, and we happen to live in one of the rare universes that permits life. Others suggest that this apparent design hints at a deeper, perhaps purposeful structure to the cosmos. The anthropic principle invites us to reflect on the possibility that our existence is not an accident, that consciousness itself might play a fundamental role in the structure of reality. The emergence of consciousness is one of the greatest enigmas of all. How does self-awareness arise from the physical processes of the brain? What is the nature of subjective experience, of thought, of feeling? Consciousness, in many ways, seems to defy explanation, suggesting that it may not be fully explainable in physical terms alone. Some philosophers and scientists propose that consciousness might be a fundamental property of the universe, like space, time, and energy. This perspective, known as panpsychism, suggests that consciousness exists in some form throughout the cosmos, that every particle, every atom, has a degree of awareness. If consciousness is indeed fundamental, it would imply that the universe is not a mere collection of lifeless matter, but a vast, interconnected web of awareness, a living system where every part, no matter how small, participates in a grand experience of existence. This view aligns with certain spiritual traditions that describe the universe as a conscious whole, where every form of life, every structure, every phenomenon is an expression of a unified cosmic mind. Such a perspective would mean that we are not isolated observers in a detached universe, but integral parts of a conscious, interconnected cosmos. The idea of a conscious universe challenges us to think differently about life and our role within the cosmos. If awareness is fundamental, then our thoughts, actions, and intentions resonate throughout the universe, influencing the fabric of reality in ways we may not fully understand. This perspective calls us to approach life with a sense of reverence and responsibility, to recognize that our consciousness is not separate from the cosmos, but a manifestation of it. In this view, our journey to understand the universe is also a journey to understand ourselves, to explore the depths of our own minds and the nature of our own awareness. The search for extraterrestrial life, in this context, becomes a search not only for other forms of biology, but for other forms of consciousness. If intelligent civilizations exist elsewhere, they too may be expressions of the universe's drive towards self-awareness, unique embodiments of cosmic consciousness. The discovery of another conscious species would remind us that we are part of a larger community of sentient beings, each contributing its own perspective to the universe's unfolding story. Our journey into the cosmos, then, is both an exploration and a communion. Each new discovery, each question we answer, is a step closer to understanding the deep unity that binds us to the stars, to the galaxies, to all of existence. In this journey, we find that science and spirituality, reason and wonder, are not opposed but complementary. Science reveals the mechanics of the universe, while wonder allows us to feel our connection to it, to experience a sense of awe and reverence for the mystery that surrounds us. As we look to the future, the possibilities are endless. Advances in technology are bringing us closer to the stars, from the development of interstellar probes to the potential of warp drives and wormholes. The dream of reaching other star systems, of exploring distant worlds, may one day become a reality. And as we prepare to take these steps, we are reminded that our journey is not just about exploration. It is about responsibility, about recognizing that our actions have an impact, that we are custodians of both Earth and the cosmos. The concept of cosmic stewardship invites us to approach the universe with humility and care. Whether we are exploring Mars, mining asteroids, or venturing into the unknown, we are called to act as guardians, preserving the beauty and diversity of the cosmos for future generations. This stewardship extends beyond physical preservation. It is a call to respect the inherent value of every world, every star, every particle, recognizing that each is a part of the same cosmic heritage. Ultimately, our exploration of the universe is a story without end, a journey that will continue to unfold for as long as there are beings to ask questions, to seek, to wonder. In this boundless cosmos, we are both small and significant, fleeting yet eternal, a spark of awareness in a universe that is itself alive with possibility. As we journey onward, let us carry with us a sense of gratitude, a reverence for the unknown, and a commitment to live in harmony with the universe that gave us life. The stars are calling, the mysteries are endless, and the journey is ours to continue. Let us explore not only with our minds but with our hearts, recognizing that in seeking the universe, we are ultimately seeking ourselves. We are part of the cosmos, connected to every atom, every galaxy, every mystery. And in this interconnected, living universe, we find a sense of belonging, a reminder that our story is the universe's story, a story of discovery, connection, and wonder that will carry on, as long as there are minds to ponder, hearts to dream, and stars to light the way. As we continue to journey into the vast unknown of the cosmos, each new discovery serves as a reminder of the universe's endless layers and its infinite potential to surprise us. What began as a quest to understand our physical surroundings has transformed into a profound exploration of existence itself, an expedition that stretches beyond the bounds of stars and galaxies and into the very fabric of reality. In the process, we are beginning to realize that the universe is not only a collection of objects and forces, but also a profound, interconnected system of relationships, resonances, and shared origins. One of the most thought-provoking areas of modern physics is the study of quantum mechanics, a field that challenges our understanding of reality at its most fundamental level. In the quantum realm, particles do not behave in the straightforward ways we observe in the larger world. Instead, they exist in states of superposition, where they can occupy multiple positions or states simultaneously until observed. This behavior is puzzling to our classical minds, as it suggests that reality itself may be inherently uncertain, a field of probabilities rather than fixed certainties. The simple act of observing a particle changes its state, suggesting a mysterious relationship between consciousness and the physical world. Quantum entanglement, another strange phenomenon, reveals a level of connectivity that defies the traditional limitations of space and time. When two particles become entangled, a change in the state of one particle instantaneously affects the state of the other, no matter how far apart they are. This spooky action at a distance, as Einstein called it, suggests a universe where separation is an illusion, where all things may be connected in ways we are only beginning to understand. If entanglement applies to every particle, every atom, and every being, then perhaps the universe is not a vast, empty space filled with isolated objects, but a deeply interconnected web, where all things influence and shape each other. This quantum connectivity has led some scientists and philosophers to reconsider the nature of consciousness itself. What if consciousness is not merely a byproduct of biological processes, but a fundamental aspect of the universe, woven into the fabric of reality just as deeply as space and time? This idea, while speculative, opens up the possibility that the universe is not merely a physical construct, but an entity that experiences itself through myriad forms of awareness. In this view, human consciousness is not isolated but part of a larger, cosmic awareness, a reflection of a universe that is, in some mysterious way, conscious of itself. This perspective aligns with theories that suggest the universe might be holographic in nature, a concept that suggests all the information in a volume of space can be encoded on its two-dimensional boundary. If true, this would mean that our three-dimensional experience of the world is akin to a projection, a deeper, underlying structure that defies conventional notions of space and form. In a holographic universe, every part contains the whole, and the boundaries we perceive are simply illusions created by our limited perception. This would mean that each of us carries within us the essence of the cosmos, a reflection of the entire universe in every atom of our being. These ideas are not only scientifically intriguing, but also philosophically profound, offering a new way to understand our relationship to the universe. If consciousness and matter are intertwined, if every part reflects the whole, then our existence takes on a new meaning. We are not passive observers of a distant cosmos. We are active participants in a vast, interconnected reality. Our thoughts, intentions, and actions resonate throughout the universe, shaping it in ways we may not fully understand. In this view, every individual life, every single moment, is a unique expression of the universe, a way in which the cosmos experiences itself through us. The implications of this interconnectedness are profound, especially as we consider our responsibility toward each other, our planet, and the universe at large. If we are indeed part of a unified cosmic network, then our actions ripple outward, influencing not only our immediate environment, but the very fabric of existence. This understanding calls us to act with a sense of reverence and care, recognizing that to harm another being or the environment is to harm ourselves and to disrupt the balance of the cosmos. This sense of cosmic responsibility extends to our exploration of space. As we prepare to venture to other planets and potentially other star systems, we must ask ourselves what it means to be responsible stewards of the cosmos. Do we have the right to alter or colonize other worlds? Or does this journey call us to a higher standard, one that respects the intrinsic value of every planet, moon, and asteroid? Space, once seen as an empty frontier for human expansion, now reveals itself as a delicate, dynamic ecosystem, each part contributing to the whole. The concept of cosmic stewardship reminds us that we are caretakers, entrusted with the privilege of exploration, but also with the duty to preserve the integrity of the universe. In this context, the search for extraterrestrial life takes on new dimensions. If we discover microbial life on Mars, Europa, or Enceladus, it would mean that life is not unique to Earth, but a natural, perhaps inevitable outcome of cosmic processes. The discovery of intelligent life, however, would challenge us even further, forcing us to expand our ethical frameworks to include other conscious beings. What rights do they have? How should we interact with them? The prospect of meeting another form of intelligent life would be one of the most transformative events in human history, an encounter that would redefine our sense of self, community, and purpose. As we continue to explore the universe, we are also learning to appreciate the uniqueness of our own planet. Seen from space, Earth appears as a fragile, blue oasis suspended in the blackness of the cosmos, a world teeming with life in a universe that is, as far as we know, largely uninhabitable. This perspective, known as the overview effect, has been described by astronauts as a life-changing experience, one that instills a deep sense of connection and responsibility. From this vantage point, the divisions between nations, cultures, and individuals dissolve, replaced by a sense of unity, a recognition that we are all part of a single, interconnected ecosystem. This realization calls us to act as caretakers not only of Earth but of the universe itself. As we continue our exploration, we are reminded that our actions have consequences that extend beyond our immediate surroundings, affecting future generations, other species, and potentially even the balance of the cosmos. This perspective invites us to live with humility, to recognize that we are part of a larger story, one that began long before us and will continue long after. Our lives, brief and finite as they are, contribute to the unfolding of the universe. Each thought, each action a small yet significant part of the cosmic narrative. In contemplating the universe, we are also drawn to questions about the nature of time, reality, and existence itself. Are we moving forward along a linear timeline, Or is time itself an illusion, a construct of our limited perception? Some theories suggest that time may be more like a dimension of space, a place that we can navigate in ways we do not yet understand. If time is not absolute, then perhaps the future and the past are as real as the present, woven together in a multidimensional tapestry. This view of time challenges our understanding of existence, suggesting that every moment is eternal, that every experience, every choice, every life is preserved in the fabric of reality. As we peer into the depths of time and space, we are reminded that our journey is both a scientific quest and a spiritual one. The universe is a place of infinite wonder, a reality that defies comprehension yet invites us to explore, to ask questions, and to seek meaning. Each discovery, each mystery brings us closer to understanding not only the cosmos but also the nature of our own consciousness, our purpose, and our place within the grand design. In the end, our exploration of the universe is not about conquering space, but about connecting with it. The stars, the galaxies, the atoms that make up our bodies, all are part of the same cosmic web, a network of relationships that binds us to the very core of existence. In seeking the universe, we are seeking ourselves, and in understanding the cosmos, we come to understand our own nature. So as we continue this journey, let us carry with us a sense of awe, a commitment to stewardship, and a recognition that we are part of something far greater than ourselves. The universe is not a distant, indifferent place. It is our home, our origin, and our destiny. It is the stage upon which the drama of existence unfolds, a place of beauty, mystery, and endless possibility. Let us move forward with open minds and open hearts, honoring the interconnectedness of all things, and remembering that in exploring the cosmos, we are also exploring the depths of our own souls. The stars call to us, the mysteries beckon, and the journey is only beginning. In this vast, infinite universe, we are the eyes, the mind, and the heart of the cosmos, a part of a timeless story that we are both writing and living together across the endless reaches of space and time. As we journey ever deeper into the mysteries of the cosmos, we come to understand that our exploration is more than a quest for scientific answers. It is a profound search for meaning, for connection, and for our own place in the grand tapestry of existence. Each new discovery, each insight into the workings of the universe, serves as a reminder that the cosmos is not merely a distant, indifferent expanse, but an intricate, interconnected reality that beckons us to explore, reflect, and grow. One of the most captivating concepts in modern cosmology is the notion of emergence, a phenomenon where simple interactions give rise to complex systems and behaviors that cannot be predicted from the properties of individual components alone. In the same way that individual neurons create consciousness, or tiny particles combine to form entire galaxies, the universe itself seems to operate through a process of continuous emergence. From the quantum fluctuations at the beginning of time to the formation of galaxies, planets, and life, the universe has been a site of endless creativity, producing structures and patterns of unimaginable complexity from basic, foundational elements. This concept of emergence challenges us to rethink the relationship between the micro and the macro, the simple and the complex. It suggests that we are more than just the sum of our parts, that there is a unique and dynamic quality to existence that arises only when elements come together. In this sense, every atom, every molecule, every being is a participant in a grand process of cosmic creation. Our lives, our minds, our consciousness, each is an expression of this emergent order, a living manifestation of the universe's inherent capacity for complexity and beauty. Emergence also leads us to consider the nature of consciousness itself. If life and awareness emerge from the interplay of simple components, then consciousness may not be confined to individual minds, but may be a property of the universe as a whole, woven into its very fabric. Some researchers suggest that consciousness could arise wherever complex systems reach a certain level of interconnectedness and organization, implying that the universe might be, in some sense, aware of itself. This view challenges the traditional separation between subject and object, observer and observed, suggesting instead a reality where consciousness and matter are two sides of the same cosmic coin. If consciousness is an intrinsic aspect of the universe, it invites us to see ourselves not as isolated beings, but as nodes in a vast web of awareness, interconnected with every particle, every star, every galaxy. In this view, human consciousness is not an anomaly, but a natural outcome of the universe's drive toward complexity. Our thoughts, our perceptions, our sense of self, all are expressions of the cosmos's own journey towards self-awareness. The universe experiences itself through us, through our lives, our dreams, our quest for understanding. The idea of a conscious universe resonates with ancient spiritual traditions that have long viewed existence as a unity, where everything is interwoven, each part reflecting the whole. In these traditions, the universe is often described as a living, breathing entity, where all things, living and non-living, are expressions of a single, boundless consciousness. Modern science, with its discoveries of interconnected systems and complex emergent properties, seems to echo these ancient insights, suggesting that our existence is not separate from the cosmos, but deeply enmeshed within it. As we expand our understanding of consciousness and emergence, we are drawn to consider the potential for other forms of awareness beyond Earth. The discovery of microbial life on other planets, or even the faintest traces of an intelligent civilization, would transform our understanding of life and consciousness. If consciousness is a fundamental quality of the universe, then it may have expressed itself in countless forms throughout the cosmos, each one unique, each one a different manifestation of the universe's capacity for awareness. In this sense, our search for extraterrestrial life becomes a search for kinship, for other expressions of the cosmic mind. The possibility of other intelligent civilizations raises profound ethical questions about how we would interact with such beings. How would we communicate? What rights would they have? And what responsibilities would we bear toward them? The prospect of contact with another consciousness, shaped by an entirely different environment and evolutionary history, challenges us to expand our ethical frameworks to include not only other species but other worlds, other forms of intelligence. This sense of cosmic ethics encourages us to recognize that all forms of life, all expressions of consciousness, have intrinsic value, and that we are stewards not only of our own planet, but of the universe as a whole. The idea of stewardship calls us to consider our impact on the cosmos as we venture further into space. The exploration and potential colonization of other planets, while exciting, bring with them responsibilities that extend beyond our immediate needs and desires. If we are to build civilizations on Mars or mine resources from asteroids, we must do so with an awareness of our impact on these worlds, respecting their intrinsic beauty and the possibility of life, however simple, that may exist there. The concept of cosmic stewardship invites us to approach the universe with humility and respect, to recognize that every star, every planet, every moon is part of a cosmic ecosystem that deserves our care. In contemplating our role as cosmic stewards, we are reminded of the fragility and beauty of Earth. Seen from space, our planet is a shimmering blue marble, a rare and precious oasis in a vast, largely inhospitable universe. This view, often called the overview effect, instills a sense of unity and responsibility among those who experience it, a recognition that we are all connected, that our differences are small compared to the immensity of the cosmos. Earth is not just our home. It is a unique and delicate world, the only one we know of that supports life in all its diversity and complexity. This perspective calls us to act as guardians of Earth, to preserve its ecosystems, protect its biodiversity, and ensure that future generations inherit a planet that is vibrant and alive. Our exploration of space, rather than distracting us from this responsibility, reinforces it, showing us the rarity and value of life. In the context of a universe that is, as far as we know, mostly uninhabitable, Earth is a sanctuary, a cradle of life that we are called to cherish and protect. As we look toward the future, the possibilities are boundless. Advances in technology and understanding bring us closer to the stars, to the dream of interstellar travel, to the potential for human colonies on distant planets. Yet, this vision also reminds us that our journey is not only about expanding our reach, but about deepening our connection. to each other, to our planet, and to the cosmos itself. In exploring the stars, we are also exploring the nature of existence, the essence of life, and the limits of human potential. This journey, at its heart, is a search for meaning, a quest to understand the mystery of existence. The universe, with all its vastness and complexity, invites us to ponder questions that have no simple answers, questions that lie at the intersection of science, philosophy, and spirituality. Why does the universe exist? What is the nature of consciousness? What is our purpose in the grand scheme of things? These questions may never have definitive answers, but the search for them is itself an expression of our place within the cosmos, a reminder that we are participants in a larger, ongoing story. In the end, our exploration of the universe is an exploration of ourselves. Each discovery, each mystery, each insight brings us closer to understanding not only the cosmos but our own nature. We are part of a reality that is both infinite and intimate, a cosmic web of relationships that binds us to every atom, every star, every living being. This interconnectedness is not just a scientific fact. It is a source of wonder, a reminder that we are woven into the very fabric of existence. As we continue this journey, let us do so with open hearts and open minds, honoring the interconnectedness of all things and recognizing that in seeking the universe, we are seeking our own origins, our own essence. The stars are not just distant points of light. They are part of us, as we are part of them. The journey is endless, the mysteries are infinite, and the universe awaits, calling us to explore, to understand, and to cherish the beauty and wonder that surround us. In this boundless cosmos, we are not merely observers. We are active participants in the story of existence. And as we journey onward, we carry with us the spark of curiosity, the capacity for wonder, and the knowledge that, in this vast, interconnected universe, we are both the seekers and the sought, forever united in the timeless quest for meaning and understanding. If you liked the video, then consider clicking on the recommendation and watch our other videos. Be sure to subscribe, and see you on our next interstellar trip.